Hello, welcome to the presentation on Microsoft Edge Accessibility. My name is Ann Taylor, and I am on the Accessibility Technical team. In this video, we will be sharing more about the accessibility features in Microsoft Edge. Microsoft's mission is to empower every person and every organization on the planet to achieve more, which inspires us to do more for our customers with disabilities. We also know that more than 1 billion people on the planet have a disability, which is why our team is committed to make Microsoft Edge more accessible. To do this, we test our browsers with customers with disabilities throughout the product life cycles, and their feedback informs future versions. While there is more to do, we are pleased to share new accessibility features to make web browsing easier and more enjoyable. Rory, over to you.
Thanks, Anne. As Anne mentioned, my name is Rory, and I'm a Senior Product Manager on the Microsoft Edge team. One of my main responsibilities is working with users with disabilities to make sure that Edge is accessible for all of our users. And that's why we work with users with disabilities early in the feature development process and consistently iterate based on the feedback. Today, I'll give you a quick overview of 2 new accessibility features in Microsoft Edge that were built in close collaboration with real users. The first feature I'll share with you today is called Page Colors. Page Colors allows users with sensitivity to bright colors or difficulty perceiving certain colors to specify a color scheme that will override the original colors on a web page. So for example, let's go to any web page. Let's say I had difficulty perceiving certain colors on this page. I can turn the feature on by going to the 3-dot menu, selecting Settings, and selecting Accessibility. Here you'll find the Page Colors option. So I'll choose this drop-down menu here, and I'll select black. And notice all the colors on the settings page have changed. If I go back to the original tab, all the other colors have updated here too, with the black color scheme. I can also change the setting to a different color scheme. So for example, desert is a pleasant looking combination of brighter colors. And here's the result on the original page. Page Colors is expected to be available later this year, and we can't wait for you to try it out. Let's switch gears and talk about live captions, a feature that enterprise customers have been asking us for. Live captions analyzes the audio played in Microsoft Edge from, say, a video or a podcast for speech, transcribes that speech into text, and then displays that text in a separate window. One really cool thing about this feature is the entire process is done locally, so no audio or caption text ever leaves your device. You can enable live captions by navigating to the 3-dot menu, selecting Settings, and then selecting Accessibility. Here you'll find the Live Captions Preview toggle. When I turn this feature on for the first time, it's going to download the language models needed for the Live Captions feature. Live Captions currently supports US English, though other languages will be added in the future. Once the download's complete, we can head over to any site with audio. So for example, I'll play this video.
At work, we're always looking for something.
And note that the caption windows actually appeared on screen in a separate window, and this is all happening real time on the device. The speech is detected in the audio and converted into text automatically in real time. The appearance of the caption window and text can be customized from Windows settings. For example, I can customize the text size, text color, and more, and these will be reflected in Microsoft Edge. Here I've selected large yellow text on a blue background, and when I flip back to Edge, the caption window reflects these customizations. Okay, that was a quick overview for 2 new accessibility features built into Edge. And with that, I'm going to throw it back over to Anne for more.
Thanks, Rory. My two new favorite features are instant answers and automatic image description, especially how they work with a screen reader like Narrator, the screen reader app that is built into Windows 11. Let's start with instant answers. Instant answers is a feature that provides answer to a certain type of queries directly in the address bar. So here I am in Microsoft Edge with narrative focus in the address bar. I can type the name of a landmark, maybe Space Needle,
FACEEELE Space Needle Observation Tower Bing search 1 of 9 selected.
or I can type something like Seattle weather.
SEATLE They're selected. Bing search Seattle weather. Answer 22 degrees Celsius sunny Seattle, United States 1 of 9 selected.
This feature is an easy and fast way to get information and works great with Narrator. The second feature is auto-generated descriptions for users of screen readers. On the web, more than one-half of the images processed by screen readers don't have text description, also referred to as alternative text or alt text for short. When screen readers encounter an image that is missing a description, it usually sounds like this.
Image.
Thankfully, Microsoft Edge has a feature that uses Computer Vision API to analyze the images that are missing descriptions and generates alt text automatically. You can enable this feature by navigating to the three dots, Settings and More menu, choose Settings, then Accessibility. Here you'll find Toggle Setting, Get Image Descriptions from Microsoft for screen readers. So let's go back to that page and move the narrator focus to the image again.
Appears to be a person sitting in front of a wall of posters. Appears to say Miriam Graham, Contoso's new chief marketing officer.
As narrator announced, the image was described, including the text in the image. While the quality of the descriptions can vary, it's better to provide some context for people using screen readers than none at all. While automatically generated alt text isn't a substitute for web developers adding their own, this feature can be a workaround if the page author hasn't added themselves. I love both of these features because they help me search the web more efficiently. At Microsoft, we value your feedback. Please do not hesitate to get in touch and share your feedback by navigating to the three-dot setting menus, then Help and Feedback, then Send Feedback. Alternatively, you can use Alt plus Shift plus I shortcut to send feedback. And together we can make Microsoft Edge work even better for you and for your organization. Check out the link in the video description for more resources about the accessibility features in Microsoft Edge. And on behalf of Rory and the Microsoft team, thank you very much for watching.
Welcome to Technical Takeoff 2022. I'm Julie Andriacola, and I'm a senior engineer with Microsoft's Fast Track. I work with customers to deploy Windows and Intune on a daily basis. Today, I wanted to show you some of my favorite hidden gems. So what's a hidden gem? It's a resource in Intune or the admin portal that can save you time and energy, and it's likely that you don't even know it's there. So let's get started. So our agenda today, we're going to look at three different hidden gems. One is the Surface Management Portal. also the Windows Release Health Dashboard, and then the Admin Center wizard where we've got some advanced deployment guides. So for our Surface Management Portal, the minimum permissions that you need is Global Reader or anything within Intune. So let's take a look at that. So if you go to endpoint.microsoft.com, you can come in here, and it's the hardest thing about the Surface Management Portal is finding it. You need to click on All Services. So we're going to click on All Services. We're going to come in here and we're going to see the Surface Management Portal. Click on Surface Management Portal, and that brings us into all the information about the surfaces in your environment. So you can see here, this is my lab, fairly small, but it puts the count of devices by type, by model. It also gives you some insights over here. So what has less than like 10% storage, what might be eligible for the Windows 11 update. You can click through these and get the list of the insights that are available. The other things that you can do in here is to take care of warranties. So if you come in here under warranty and coverage across this top, it's going to show you here the expired, what's in coverage, what's coming up on that. So if I click here, I'll again see all of my machines are currently out of warranty, but it does show you when they started and when the coverage ended. And lastly, support. So it kind of provides a one-stop shop here for troubleshooting and taking care of any support issues related to your Surface devices. You can actually open up requests right here, and this link takes you to the Surface Deployment Toolkit, or Surface Diagnostic Toolkit, which is an excellent resource to individually check a machine to see what's going on and have that ability there. So that's the Surface Management Portal, and let's take a look at our next item. So the Windows Release Health Dashboard. So this is an excellent resource. It's not only, there is a public facing one, but today I'm going to show you the one that's inside your tenant, because there are times and things, there are things in there that may be beneficial to you that's not very easy to find or visible on the public facing. The minimum permissions that you need here is the Service Support Admin role. So let's take a look. We're going to go outside of Intune here and go over into admin.microsoft.com. So this is the Microsoft 365 Admin Center, and there's a lot of really good, interesting stuff in here. So if you've not spent any time, you will find that there are device management pieces in here that will be helpful for you. So we're going to say Show All, and we're going to come down here to Health. So when I open this up, you can see we have a number of different things, but today we're going to look at the Windows Release Health. So what this does is gives you very quickly, within a few clicks, to see all of the known issues and any historic issues that these devices have by release. So let's say you're thinking about implementing Windows 11 21H2. Let's see what kind of issues they currently have. So today, as of the beginning of October, we've got a compatibility issue with the Smart Sound technology drivers and Windows 11. So let's take a look at that. Click on that, and it's going to give you some details here. Let you pass back feedback if you're experiencing this issue, see the latest message on it. It will also show you the safeguard IDs right here, these numbers. So if you are leveraging the reporting for safeguard holds, which I hope you are when using Windows Update for Business, it's going to let you know what those numbers are for that reporting that's available to you. So again, a lot of information. A lot of times we can put additional details in here that we may not put on our public facing. It's a great way to come in here. You can also look at the history of it and all the changes that have been made relating to this particular issue. So again, very fast, very quick to work with. It also includes Server OS. So just an excellent resource that a lot of people don't know is here. And again, you will need the Service Support Admin role at a minimum to see this. All right, let's look at our last hidden gem, number 3. This is the Admin Wizard, the Advanced Deployment Guides. You can see them by going to aka.ms Setup Guidance. Here you're going to need at least an administrative role, such as Intune Administrator or the Office Apps Administrator. And these are roles that are designed to guide you in setting up your environment. And you can find these underneath Setup. And we're going to go right to the Advanced Deployment Guides. There's a lot of information in here, and I encourage you to spend some time walking through this. I'm just going to highlight some of the guides that are very interesting and that may be useful for you when you're thinking about device management. So of course there's Intune. You want to get started with Intune, come into this setup guide, and it's going to, 1, check to make sure that you've got the required licenses, and then you can customize it, and it'll actually give you a survey of what you want to do, like or maybe you have your existing devices already, but you also are interested in some mobile. Yes, and as you answer these things, you can see it's changing over here, the different pieces that you are going to need to do, and it gives you all of that information. And down here we get endpoint analytics, and we're going to say next. So it's going to give you information here about roles that are necessary, and then there's steps to walk through. And some of these steps may be just links to our documents, but a lot of these will help you actually do the work. So if you need to set up your MDM scope, come in here. I'm going to say it's going to go to all, or maybe I need it just to some, and then I can add the group of the folks that I want to enroll. Let's just say we want to do the Contoso team. And now when I save, this is actually setting it in your Intune, into your tenant. So you're actually making changes when you're walking through this. Maybe you want to get started on autopilot device enrollment. Not quite sure what to do. They've got a button here that's going to automate you and the ability to walk through and get those created. So you just simply click on to start the guide. It's going to give you an example CSV of the device information and simply walk you through how to set up autopilot. Again, a lot of good things. When you walk through here, you say, I want my Windows 10 policies. And yeah, I'm going to take all of these here and let's just select them all. I'm going to save my policies and give them a name here, and that's going to put a prefix on them for you. And some app protection policies. Again, these are great for getting some examples of what are best practices. All right, so we've walked through all of that. So if I come over and I go to endpoint.microsoft.com, I come into Devices, Windows, under Configuration Profiles, look at all these things that were created for me. So I have some examples to go look at. Compliance policies as well were things that we created. We also created some app protection policies. Again, these are all here now for you to take a look at, and they're not going to do anything in your environment until you assign them, but it gets you started, which is exactly what most customers are looking for. So that's your guides within here. Just take a look at all the different products. Even within Teams, there's an excellent one here for Surface Hub that I like to point out. Even helps you create the necessary accounts to get all that working correctly. So thanks so much for joining me today and all of these hidden gems. I hope that you found some things that you didn't know were there, and that will help you as you move into these, taking advantage of these modern endpoint management. Thanks so much.
This video shows how to enroll your tenant in the Windows Autopatch. To get started, sign into Microsoft Endpoint Manager as a global admin. Then, find Windows Autopatch on the Tenant Administration blade. If you don't see it, you don't have the required licenses to take advantage of this service. See our Docs page for more information. Then, select the checkbox that allows our readiness assessment to run, followed by Agree to begin the assessment. If your tenant status is not ready, check out the video at aka.ms/autopatchtenant to learn how to address the issues we found. As for any advisory tasks you might see, you can finish enrolling your tenant before addressing these. When your tenant status is ready, select Enroll. And then, the next page requests consent to allow Microsoft to perform certain actions in your tenant. Select the checkbox and then select Agree. We need some contact information. Select Complete to begin setting up Autopatch for your tenant. When we're done, you'll be ready to register your devices. On the Devices blade, select Windows Autopatch Device Registration to begin adding your devices to the required Azure Active Directory group. Select Add Member, choose the devices you want to enroll in Autopatch, and then select Select. Back on the Devices blade in Endpoint Manager, it might take up to an hour for your devices to appear while we complete the device readiness checks. But you can select Discover Devices to try populating the list sooner. Once you see a list of devices on the Ready tab, you just need to set up your test ring. For more how-to information, see aka.ms/autopatch.
Log into the Azure portal to easily set up a Windows notification resource. Navigate to the Windows Notification Service page and begin setup by selecting Create. On the WNS App Registration page, provide the subscription and resource details. Next, create a name for your WNS resource. Under the Register an Application section, there are two options. You can dynamically create a new app or choose an existing app. Onboarding supports both packaged and unpackaged apps. For the existing app option, a drop-down will allow you to select from a list of apps associated with your directory. For this, we will demo how to create a new app. In the name field, enter the user-facing display name. Select the checkbox here if it is a packaged app. For packaged apps, you will be required to fill in the package family name. We will create an unpackaged app. Next, select Create and you're done. It's that easy. Once your resource has been created, you can manage it from the Overview page. This page provides all the information you need to send notifications or manage your resource. Azure App ID and Azure Tenant ID are needed to request an access token. Object ID, which is required for channel URI requests, can be found here under Managed Application in Local Directory. Set up or view your secrets using this link. Under the Notification Details section, you can now track your monthly usage against tier limits. Proactively upgrade your tier using the link above when you get close to your limit.
Good morning, good evening, or good afternoon. My name is Anton Holloway. I work with the Fast Track team, and today we're going to be discussing shared iPad device enrollment during this Microsoft technical takeoff. So a few things before we get started. We're going to discuss the prereqs. We're going to go into the ABM and make sure our MDM server is set up correctly. We want to make sure that we're using an iPad that's at least at 13.4. We want to make sure that there's at least 32 gigs of storage on that iPad because we're going to be working with multiple profiles potentially. Want to make sure that our Apple Push certificate is set up in the MIM console. Apple Device Enrollment Token, we want to make sure that that's going to have the appropriate user affinity settings. And we're going to discuss Managed Apple IDs, in which we're probably going to do that first. So let's go ahead and jump into our ABM portal.
In order for users to be able to log into the shared iPad with their Office 365 credentials, you must go into the ABM portal and actually add that domain and federate it. So here, I'm in my ABM portal. I'm going to add a domain from my dev tenant. Okay, so now that we have it added, gonna ask me to verify. So once I verify, it's gonna give me a text record. I'm gonna copy. Now this step is gonna vary depending on who you use for your DNS provider. I use GoDaddy. So I'm gonna click add here. It's gonna be a text file. I'm gonna put at. And we're going to add record. So this generally takes about 10 to 15 minutes. So we're going to go back. Right, now that we're back to the techproitc.net text record, we're going to hit check now. And we're verified. Now we're going to federate, and we're going to sign in with that address. Right, so now it's going to add Apple, the ABM, to my profile. I'm going to consent to it. So this is going to show up in my enterprise applications and accept. So notice I received an error when I attempted to set up the federation. That is completely okay if you already have an account that you're doing the same thing with. Because these are separate tenants in my live environment, I cannot have more than one. So while I can have as many domains as I want, I can only have one tenant. But for the sake of this demo, that's completely fine. We're going to continue as if it is working. And then once we get to the actual iPad, we'll use an account that's already established. So now that I am quote unquote federated, my next step is to go to directory sync. And I'm going to edit. And I'm going to generate a new token, because what this is going to allow me to do is grab those accounts from the Azure portal and bring them over to the ABM so users can log in with their Office 365 credentials. So we're going to generate a token. I'm going to leave this window up. And what should have happened is I should have a ABM application created. And notice we're still in the same tenant, so the application did get created. Okay, so now that we have this set up, we're going to go into provisioning. I'm going to click Get Started. We're going to change the provisioning mode to automatic. And we're going to copy this information over. Okay, and we're going to paste. And then we're going to get the token ID. We're going to paste. Test the connection. And our connection is successful. So now that our connection is successful, notice our token has an expiration date. Everything is turned on. And if we were to do so the directory sync has already happened. In my case, if I go look at my activities, we can see that I currently have sync set up, and I do have actual accounts added so users can log in with their Office 365 accounts. Now that we're done with the ABM portal, let's talk about device enrollment within Intune. So an assumption being made is that you already have enrollment program tokens from your ABM portal into Intune, so your devices can be automatically synced and the default profile can be assigned. So in my case, all of my iOS and iPad devices are assigned to my corporate device profile, which we'll go through. When we take a look at that profile, a few key things I want to point out. I'm enrolling without user affinity, which is a requirement for shared iPad. The devices are supervised. I'm locking my enrollment. This will prevent users from unenrolling their devices. The purpose of this demo is shared iPad, so we want to make sure this is yes. Maximum cache users is a question I get a lot. I have it set at 15. You can technically go as high as 101, but for a 32 gig to 64 gig iPad, the recommendation is a maximum of 24 users. The other setting I want to point out is the fact that I am not requiring shared iPad temporary sessions. So when we take a look at the iPad, you'll see that there would be an option for guest. And that's it. So the rest, you set these up to your own preference. But again, the only settings that you want to make sure that you have set up is enroll without user affinity. It needs to be supervised, and it needs to be in shared mode. Now we're actually going to watch a device go through the enrollment.
Now that we have the iPad ready at our home screen, we're just going to get it set up and connect it to the internet so it can pull down our profile. Okay, so it looks like I'm connected. Take a few minutes to activate the iPad. Now I get my remote management screen. I'm going to hit next here. So as you can see, the name of my demo tenant. Now it's downloading the last couple of configurations from the profile I set up. So just a bit of a disclaimer here. If this would be your first time setting up shared iPad, you will get an Azure login splash for the user to enter in their Office 365 credentials. Since my accounts have already synced up to the ABM portal, I won't get that splash, but we're going to go through in a moment what you'll see for existing users. I'm just going to give the iPad a few moments. All right, now it's going to ask me to log in with my Apple ID. Remember, this is going to be my Office 365 account or Azure AD account. And that is called a managed ID. This is different from a traditional Apple ID. So, for example, I can't go to the store and buy things with this ID. So I'm going to type in the name of my tenant here. Now it's asking me for a passcode. Again, since I'm an existing user, I already have a passcode set up, so I'm just going to use it. And now it's pulling down my credentials and profile. All right, and now I'm in. So this is my profile. Notice my name at the top. Now if I want to get out of this profile, and let's say I wanted to use a guest profile, I can sign out here. And I can log in as guest. And notice when I use guest, it says data will not be saved. Hit the home button to sign in again. So this is useful for true kiosk style devices where you're in a medical office and you want people to sign in and be able to use the iPad multiple times without being able to save data. So now I'm in the guest profile. Notice it says guest here. And I am going to use another test account that I set up. Again, if this is the first time using the account, I would be prompted to set up a passcode. If a user forgets their passcode, that can be reset ABM. So I'm going to click Other User, and I'm going to type in the name of this user. And now it's signing me into a separate profile. Just giving it a bit of a few moments. And now we're in. And notice the name has changed. And if I want to sign out again, I just simply sign out. And notice it saves my documents and data this time. And now when I get back to the home screen of the iPad, I have two profiles I can choose from to log in. And now when I go back to my Intune portal, I can see that that device was enrolled, and it was enrolled by a shared user. The other way you can tell if a device has been enrolled as shared, we can go into hardware, and we can look, and we see that the Apple device is shared. So now I can sign in and out with different profiles. That's being synced through ABM. And that is the end of my demo. I hope you all enjoyed this demo. Have a great rest of your day.
Hi, my name is Colleen Williams, and I'm a Principal Product Manager on the Microsoft Edge team. Today, I want to introduce Microsoft Edge Workspaces. As with many new features, Workspaces began with small observations that led to a big insight. When we engaged with users who now have more flexibility in how they work, we saw that the browser had become a center for digital work. They'd open tab after tab throughout their day, only to lose track of the ones they truly needed, or worse, they'd forget why those tabs were even open in the first place. What we discovered was that the explosion of tabs caused browser overload and was indicative of another behavior accelerated with digital work: sharing links. Sharing links is so easy, in fact, that we don't even think about it most of the time. We quickly paste, send, and move on. The result? Death by 1,000 emails and chats, full of links, sent one at a time. And then we open even more tabs so we don't lose track of what was sent in the link. It was from this insight that we started building Workspaces, an easier way to manage and organize links and resources intuitively in the browser. But the pain of chasing down one-off links isn't just felt by individuals. It's multiplied when working on a project with others. Keeping a group of people on the same page by sharing one-off links is hard. Projects are fast-moving, and the relevant data, drafts, and documents change frequently. And if everyone is working off a different picture, your group is not at their best. So we evolved Edge Workspaces from an individual tool to a vision for a real-time collaborative browsing experience to not only organize the sea of links, but also to align groups with a single view of the websites and latest working files that are important on a project. All this in the browser where everyone is already spending the majority of their time. Early testers call Edge Workspaces a time saver, and that it offers efficiency since we are all working off the same material in an intuitive way. Edge Workspaces is a new browsing experience that enables you to create a dedicated browsing window with its own set of tabs, so related items that you use for a project are all housed together. Each of these workspaces can also be customized, for example, with a project name and visually identifiable with a color you see in the menu in the toolbar. Workspaces are not just a group of tabs, but they're also enhanced with group functionality. Each workspace can be shared, allowing you and your group to stay on the same page for a given project, in an easy browser experience you know and use every day already. There is presence shown with profile pictures, so you know if a colleague is working on a particular tab. Built on top of the Microsoft Fluid framework, actions you perform like opening, closing, and navigating to tabs are automatically shared in real time with your colleagues in a workspace. For example, if you transition from a working file to a final file, you can close the tab for the working file and open the final file as a new tab for everyone across the group. Because who doesn't hate working on the wrong file? You can also add a shared favorite, see the history for the workspace, and use other Edge features you know and love like vertical tabs. Let me show you how it works. Cara is joining an existing project as the new design lead. She's excited to work with the group. Usually, Cara would receive emails and chats with numerous websites and file links to bring her up to speed with the group's project. Instead, the group uses a shared Edge workspace where all their project links open as tabs. Using one simple link, Cara opens the shared Edge workspace. She's pleasantly surprised to see the group's sites and files are ready for her all in one place. Since she uses the browser every day, the Edge workspace is instantly familiar. Cara sees that other members of the group are in the Edge workspace as well. Since the Edge workspace is shared by the whole group, she already feels more connected. She sees that most of the team is on the first tab looking at the project tracker. In the background, the group leader pings that the group needs to put together a short executive review for tomorrow. In real time, the leader opens a new PowerPoint presentation as a tab, and the group knows exactly where to start. Although she just joined the group, Cara sees how she can help with the executive review right away. She pulls up the file with the latest product designs in the Edge workspace. She alerts the group and sees them move to her tab to grab images of the product. Her teammate is grateful that he didn't have to hunt around for the images. Cara loves how fast she was able to contribute to the group already. With Edge workspaces, groups can stay on the same page by sharing the same tabs. Users are guiding our way forward on Edge workspaces. One common request has been, will I be able to use this at home with friends and family too? We are inspired by the different needs we are hearing from users, from planning travel, to organizing a birthday party, to working on a volunteer project. It turns out that having a clear picture of the working files and important websites in a project with real-time presence and updates is something that everyone wants. We are currently inviting companies and organizations to join a public preview of Edge workspaces to help their employees get out of the sea of links. And stay tuned for a preview for the general public as we heard the request loud and clear. No one should waste time chasing down links or work with a fragmented picture of their project. Save time, avoid working on the wrong file, and stay on the same page in real time with Microsoft Edge workspaces. It's simple and intuitive because workspaces are in the browser that you already know and use every day. With Microsoft Edge Workspaces, you and your group can focus your best energy on moving forward together. Join the Enterprise Public Preview today.
Hi everyone, I'm Steve Dicitis, a Program Manager in the Azure Edge and Platform Fundamentals team. Let's look at the improvements we've made to the Windows 11 version 22H2 Update Foundation, including a demo. With the release of Windows 11 version 21H2, we made significant improvements to Windows Update Foundation. This includes a redesigned cumulative update resulting in a 40% reduced package size, reduced download size for those devices more current than others, improved update orchestration via the Unified Update Platform or UUP, and increased support for servicing language packs. With Windows 11 version 22H2, we build upon this strong update foundation with performance improvements for both feature updates and cumulative updates. Let's take a closer look. Starting with feature updates, we reduced the download size of each client by redesigning how we handle Microsoft developed apps that ship with Windows. Specifically, we enabled a conditional download during a feature update, acquiring these apps from Windows Update only if needed, reducing feature update download size. Next, we streamlined language delivery, eliminating 22 LXPs that have very low usage and are declining, and we removed 43 LXPs from the UUP feature update that have an associated language pack. The result is reduced size for the language and optional feature release media and smaller UUP-based feature updates in WSUS when we ship that in the future. We also integrated .NET Framework updates into the UUP-based feature updates. The result is one less reboot required after moving to Windows 11 version 22H2. This improvement is coming soon. For cumulative updates, with Windows 11 version 21H2, we reduced the size sent to each client over the network. We structured the cumulative update in a way to request only those files that have changed. And now for Windows 11 version 22H2, we extended this design to also cover optional content. Next, we reduced the disk footprint of the cumulative update, returning about 250 megabyte per cumulative update to the users. In addition to smaller downloads and smaller disk footprint, we've made significant progress on reducing the time required to download and install a cumulative update. Let me demonstrate. This video shows a side-by-side comparison of Windows 11 version 21H2 on the left and version 22H2 on the right. Both are acquiring the same cumulative update starting at the same time. We've reduced the time with version 22H2 through a collection of low-level performance improvements. I'll highlight two of these. First, we moved from a single-threaded to multi-threaded hydration of the newly serviced components. If you recall, in Windows 10 version 1809, we introduced a model where reverse and forward differentials can be combined to create a smaller cumulative update package compared to the previous Express technology. And by applying these reverse and forward differentials in parallel, we've significantly reduced installation time. Second, we are also much more efficient in handling the cumulative update metadata, such as component manifest files. Specifically, we've reduced file system overhead by expanding these files into a single temporary file instead of thousands of smaller files. We've also combined some common operations between the download and the install steps, again, significantly improving performance. In our internal lab-based testing, based on Windows 11 version 21H2, with the November 2021 cumulative update installed, followed by the installation of the June 2022 cumulative update, we see the following results when compared to the Windows 11 version 22H2 servicing stack. A reduced download time by about 37%, reduced online install time by 12%, and reduced CPU time by over 18%. There you have it, a brief overview of the Update Foundation improvements we've made for Windows 11 version 22H2. Have questions? Contact me on Microsoft Tech Community or at the next edition of Windows Office Hours. Until then, thanks for watching.
Hi, my name is Dave Weston. I'm the Vice President of Security and Enterprise here at Microsoft. Today I'd like to answer some questions about the Windows 11 security baseline, Secured-Core PCs, and Microsoft Pluton. We know there can be some confusion around these topics, so let's talk about what they are and what they each bring to the table. With hybrid work on the rise, we knew it was time to raise the security baseline. Organizations need to be ready to protect sensitive information anywhere. With Windows 11, our customers can enable hybrid work and new experiences without compromising security. Windows 11 raises the security baseline with new requirements built into both hardware and software for protection from chip to cloud. Features that now come with any Windows 11 device include TPM 2.0 for hardware-rooted trust, virtualization-based security, advanced encryption, and Windows Hello for passwordless protection. Secured-Core PCs build on the Windows 11 security baseline to provide an extra layer of protection against firmware attacks. These devices enable advanced hardware, firmware, and software protection by default. You get an elevated protection from the moment you unbox and turn on your Secured-Core PC. Cybercriminals are rapidly evolving their attack techniques, threatening devices at the deeper firmware level. The September 2021 Security Signals Boost report shows that 87% of enterprises surveyed have experienced at least one firmware attack in the past 2 years. Firmware, which runs below the operating system at the core of the device, is emerging as a primary target because it's where critical operations like Windows startup happen. Attackers often try to overwrite firmware by using rootkits to compromise protection, such as the secure boot policy. Some advanced firmware protection was available before, but you need to find the right device with the right specifications to support it. Then you had to configure settings to enable those features. To solve these challenges, we worked with OEM partners to deliver a new category of specialized devices called Secured-Core PCs in 2019. Secured-Core PCs offer customers simplicity as well as significant security benefits. They provide additional measures at the firmware level, and they ship with these protections already turned on and enabled. As a result, customers can get advanced protection without needing to find the right device and then make complicated changes to settings. Protecting devices at the core can help strengthen an organization's zero trust security posture to help protect data and access anywhere. Enabling powerful default protection also means the security decision makers can invest more time and resources in value-added innovation instead of constantly protecting against an onslaught of attacks. According to the March 2021 Security Signals report commissioned by Microsoft, security decision makers who invested in Secured-Core PCs reported a higher level of satisfaction with their security compared to other devices. The table below shows some of the core features that deliver this advanced protection. You can check out Secured-Core PCs from our OEM partners at aka.ms/Secured-Core PC devices. Designed by Microsoft and our silicon partners, Pluton is a security processor that integrates directly into the silicon of the CPU to provide hardware root of trust at the chip level. Embedding Pluton in the chip eliminates the need for physically exposed and potentially vulnerable communication paths between the CPU and the hardware root of trust. By delivering security at the core, Pluton aligns with our vision for the future of Windows PCs, where hardware and software tightly integrate in a unified approach to help eliminate entire vectors of attack. Secured-Core PCs come with integrated layers of protection enabled by default at all levels of the device, including firmware. Pluton is a security processor that our OEM partners can add to a Windows 11 device, including Secured-Core PCs, to provide additional hardware protection for sensitive assets like credentials and encryption keys. Another distinction is that with Pluton installed, Windows 11 devices receive security processor updates directly from Microsoft to simplify security management. Customers in a data-sensitive scenario want the highest level of Windows security. When a processor is located on a separate, discrete chip on the motherboard, the communication path between the root of trust and the CPU can potentially be vulnerable to physical attack. The revolutionary design of the Pluton security processor helps eliminate this risk by embedding root of trust directly into the CPU. Pluton also solves the security challenge of keeping firmware up to date. Without Pluton, updates to security firmware typically come from a variety of sources, adding management complexity and potential risk to systems lacking the latest protection. Pluton also provides a flexible, updatable platform for running firmware with security functionality authored, maintained, and updated by Microsoft. Pluton is integrated with the Windows Update service, benefiting from over a decade of operational experience, reliably delivering updates across more than 1 billion endpoint systems. You can get devices with Pluton from our OEM partners. Pluton will be continuously updated through Microsoft's Windows Update to provide the latest security functionality. You can find devices with Pluton at aka.ms/Pluton devices. All Windows 11 devices require a TPM 2.0. If a device has Pluton, then Pluton can fully meet the Windows 11 requirement for TPM 2.0. Pluton can be used with a TPM 2.0 or as a standalone security processor. Customers can ask their OEMs for a configuration that enables Pluton for their specific needs. Secured-Core PCs and Pluton were originally introduced to provide an additional layer of security for data-sensitive, highly targeted industries like healthcare, government, and financial services. However, the shift to hybrid work has introduced new security risks as more employees are distributed around the globe. According to data from the September 2021 Signals Security Boost report, 75% of security decision makers surveyed at the vice president level and above feel that the move to hybrid work leaves their organizations more vulnerable to security threats. And Microsoft's 2022 Work Trend Index report shows that cybersecurity issues and risks are top concerns for business decision makers who worry about issues like malware, stolen credentials, and devices that lack security updates, as well as physical attacks on lost or stolen devices. Therefore, our vision is to raise the security baseline for everyone by making Secured-Core PCs and Pluton the norm in consumer and business devices alike, so that we may all benefit from these advanced security solutions. Not necessarily. Pluton and Secured-Core PC are independent offerings. Devices could support Pluton, Secured-Core PC, or both at the discretion of the OEM. To be considered a Secured-Core PC, a device must have multiple layers of protection enabled. Pluton can provide additional protection to any supporting Windows 11 device, including Secured-Core PCs. Thank you for listening. I hope this answers some of your questions around Windows 11, Secured-Core PCs, and Microsoft Pluton.
Hello, my name's Jay Simmons. I'm a software engineer here at Microsoft. I work in the Active Directory team located in Redmond, Washington. We've been working hard to build a new version of the product known as Local Administrator Password Solution, aka LAPS. In this video, I'm going to demo some of the new LAPS Azure Active Directory features. If you haven't yet seen the LAPS deep dive video, I do recommend that you watch that first just for additional background. Please note that at the time of this recording, the LAPS Azure AD scenarios are currently in private preview. I know that many customers are going to be excited to try this out for themselves. The feature will be opening up to a broader audience later this year. In addition, not all of the planned Azure Portal Management experience are available yet for demoing. So what you're looking at on the screen is two virtual machines. The virtual machine on the right is going to be playing the role of our managed client device. This is going to be the device that we're going to configure to back up passwords to Azure. The virtual machine on the left is going to play the role of our management client. This is going to be the client machine that we're going to use to retrieve the passwords from Azure. So before I get into that, I do want to show the one example of how to configure the client device, and this is how we're doing it today. So you're looking at a Microsoft Endpoint Manager portal, and I've created a device configuration profile called LAPS Policy, and I've assigned it to a group, and I want to look at the configuration settings. So you can see here that I've set majority of these. So we're going to be backing up our passwords to Azure. We're going to have passwords that are 32 characters long. We're going to be managing a custom local account called LAPS Admin. I've disabled post-authentication actions for the purpose of this particular demo video. And we're going to have a default password age and days set to 11 days long. So with that in mind, now for demo purposes, to avoid delays, I've already configured that policy on the client. What we're going to do now is tell the client to wake up and process that policy. Now there is a new PowerShell module in Windows called LAPS, and you can see that there's a whole slew of commands. Now we're not going to go through all of these, and many of them actually are specific to the on-premise Windows Server Active Directory scenario. So what I want to focus on first is this commandlet. Now what this commandlet does is it wakes up the local LAPS client in Windows and says, hey, I want you to go process the currently in effect policy right now and do whatever you're supposed to do. So we're going to run that. And now be aware that the new LAPS has a dedicated event log channel, and this is what it is. And everything that LAPS does gets logged to this channel. So let's take a look and see what it did. So 10,003 is a good event number to be aware of. This is the signature event with which all policy processing cycles begin with. And so we get a policy configuration dump, so we know that it came from Intune, and we're backing passwords up to Azure Active Directory. Here's the name of the custom local account. Password age and days is 11. Password complexity was not specified in the policy, but it defaults to 4, which is the most complex version. Passwords will be 32 characters in length, and we disabled post-authentication actions. So what this does is it gives you a precise dump of the policy that is in effect when the LAPS client woke up at this point in time. And this is just an extra confirmation. We're sending passwords to Azure Active Directory. Why are we here? We're here because an administrator told us to process the policy. And it realizes it needs to update the password. So under the covers, it created a new password, and now it just sent it to Azure. Now this is a sign. This event tells us that we got a successful response back from Azure. That's a good thing. That's good. And we then turned around and the local client updated the local admin account with that new password. We always track the name of the account and its RID just so there's no possible misunderstanding about which account was updated. And we're done. So that was good. So now that the client has done what it's supposed to do, let's go over here to the management client device. So the same PowerShell module is used. So in this case, for retrieval, we use the get LAPS AAD password. So password retrieval for Azure Labs is always done over Microsoft Graph, and so this commandlet is not doing anything particularly complex. It's simply wrapping Microsoft Graph queries for the right endpoints and then parsing the results. Now, this commandlet isn't standalone. It is built and uses other commandlets from the Microsoft Graph PowerShell library. So in order for this inbox Windows commandlet to work, you do need to install the Microsoft Graph PowerShell library, and I've already done that in this case. So before we can use this commandlet, we have to log into Microsoft Graph. So let's do that here. Oops, didn't copy it correctly. So that worked. And now we're going to log in or retrieve the password for the. So what I'm passing here is the name of the device on the right. Now there are two graph permissions associated with Labs. There's the basic permission, which is what allows you, which gives you permission to retrieve the information that you see displayed here. It doesn't give you permission, basic permission doesn't give you permission to retrieve the actual passwords, but the basic permission is really intended for like a monitoring app that wanted to make sure that the managed devices are not getting stale with respect to their lapse passwords. Now, there is going to be a role-based access control configuration in the future to allow you to configure custom authorization policies for retrieving lapse passwords. Currently, this RBAC policy is hard-coded to global administrators, device administrators, and Intune administrators. I'm logged in here as a global administrator, and so that does give me permission to retrieve the password. And so we can specify to the commandlet that's what we want. So a little bit different of a return result. Notice that we do get the account name. It's always stored side by side with the actual matching password. We get the password update time, so that was done just a couple minutes ago. And notice that there's an 11-day difference roughly, or exactly, between the update time and the expiration time. The clear text password, the clear text password is returned, but it's displayed here in the form of a secure string. For testing purposes, we can request that it be dumped as plain text. And you'll notice that here's the clear text password, and this is I'm not going to count them, but it's 32 characters long. So let's see if that password actually works. Now, I'm not going to do an interactive logon, but let's do a run as of that local account to see. Voila. So as you can see, we configured the device to back up its lapse password to Azure for a custom local account called lapse admin. The device woke up, it processed that policy, stored the password in Azure. We went over to the management client, we queried Azure for the password, got it here from this information, and then we were able to go back to the managed device and use that for login. It's very important to use green text here for the run as and cyan. No, I'm just kidding, that's a joke, but those are my favorite command console colors. But you can see from a scenario perspective that the password was round-tripped all the way from the managed device up into the Azure Active Directory, and then retrieved on the management client, and then turned around, and we used it successfully for authentication to the managed device. So I did want to show a couple more things. So this commandlet right here is used by a local administrator to tell the local lapse client that it must reset the password immediately. So when you run this commandlet, this is done arbitrarily on the spot without reference to any previous password expiry times. This is what you would use if you were wanting to perhaps recover from a security breach, or if you were logged into the device as a lapse admin and you wanted to clean up you wanted to reset the password right before you logged off. This would be a good thing to run. So we're going to run this because I do want to show you something else. And Remember, everything is in the event log, so we're going to skip down here and watch the flow as the local labs client updates the password. So same basic, the policy has not changed. It's still in effect. It's dumped every time. We're backing up to Azure AD. It's very clear we're updating the password, period, because you told us to. Sending the password to Azure. We got a success response from Azure. Updated it on the local account, and we're done. So there is limited support in Azure, in this Azure Labs feature, for password history. So it's not a huge number of previous passwords. Currently, that may change in the future. But let's just fill up the passwords a little bit so that we can check out what that looks like. Now, I don't recommend that you frequently rotate the password like this. It's not advisable except for either testing purposes or perhaps in response to a security breach. So let's go back over here and retrieve the password. And you'll notice that we have a different password than what we had up before, and the update timestamps and expiry timestamps have changed. Now we'll go one further step and ask for history, and this gives you an idea. So there's a limited support for password history. It isn't a large number of them currently. You can see that the older passwords no longer have an expiry time, but you can tell by bracketing and their password update times, which are what the order was of the updates. Okay, I hope you enjoyed that. I do want to show you one more thing. So we have an extensive set of online documentation that I do encourage you to take a look at. There's a set of docs here for the mainline scenario, and we also have a separate set of docs just to cover the details of the local administrator password solution, CSP, for management from the cloud. All right, so I hope you enjoyed that. Please don't forget to watch the Labs deep dive video. That'll give you a lot more information about the feature set, and as well as the online documentation. Thank you for watching.
Hi, so we want to talk about Zero Trust and how Windows builds device health. One of the critical features that we've built into Windows is called Attestation, where we verify if a device can be trusted by itself, if the OS booted correctly, and if all the right set of security features were enabled. With Intune, you can leverage all of this goodness with Intune device compliance. Today, I'm just going to walk through how attestation is done on a device and how it feeds into device compliance. So we have described how the attestation process works, but essentially what we're doing is we're looking at the device and figuring out what happened on the device during the boot. Was it valid? And then point on, we only allow secured apps or Azure resources to be allowed on your devices. Now, this is a descriptive page for device health, but I really want to talk about how Intune takes advantage of this device health feature on Windows. So we have CSP integrations both on Windows 10 and Windows 11. However, we want to focus on Windows 11, which has a whole bunch of new security-related features that are built into this. Now, what I've done is I have gone ahead and set up an attestation service against which I will perform an attestation of my device. And we have steps listed down as to how you can go set up your own attestation and how the whole process works. For this purpose, I have created an endpoint already. And here is a policy that I'm using for attestation, which is very Windows 11 specific. We're looking at boot properties, BitLocker status, ELAM driver, kernel debugging, dep policy, flight signing, test signing, and a whole bunch of security features like HVCI, IOMMU, boot managers, OS revision list, safe mode, and a whole bunch of things, right? Now, what I've done is I have set up a sample client that I will run attestation against this service, and let's see what the output is. So I have everything set up. I'm gonna hit run. You can see that it takes a couple of seconds for us to pick up things from the device, talk to the attestation service, and get a report back. For the purposes of this demo, I have already decoded this boot JOT file, and this is how my report looks like. You can clearly see we have validated a whole bunch of things in the policy, which you could see here, is now also available to you in the JOT token, which has been verified by the attestation service to say, hey, your Windows 11 device that booted did boot with BitLocker enabled. This was the enabled value, boot debugging state, code integrity state, and so on. And now this token gets used in Intune device compliance to make a compliance assessment of your device and keeping your devices and enterprises secure. Thank you.
Windows Autopatch automatically assigns devices to testing groups we call rings, except for the group labeled Test. The test group contains the initial set of devices that receive updates. It should not include any mission-critical or VIP devices. To add devices to your test group, select Devices on the Devices blade in Microsoft Endpoint Manager. Once there, select the devices you want to add, and then select Device Actions followed by Assign Device Group. In the Select Group list, select the Test Group. Select Save to save your changes. And that's it. You'll see a message indicating your devices are scheduled for assignment to the test group. For more how-to information about Windows Autopatch, see aka.ms/autopatch.
Thanks for watching the demo. Let's get started with Android Remote Help. I've got an Android device that's enrolled. It's currently in sleep, and we're going to do a new remote assistance or remote help session. I've got three choices: screen sharing, full control, or unattended. And because this device is currently sleeping, let's go ahead and do unattended control. I'll choose Launch Remote Help. And the first thing we get is an audio notification. And in the event that somebody was there and had the screen up, they would see that there's an attempt to complete a remote help session. And since there was no response, and this is unattended, we go ahead and just pull up the screen. Now you notice it's asleep, so we're seeing both black on the screen as well as in our remote help session. So I'm going to go ahead and just press the button to wake it up. And you'll notice it gets woken up remotely. And we'll go ahead and click, and now we're active in the device. So pretty simple and straightforward for unattended remote help. I could now go do anything that I needed to remotely on this device. We'll go ahead and leave. And now that I've got the device I'll go ahead and log into the device, and let's do a new remote assistance session with just screen sharing. Once again, I'll launch Remote Help. We'll get a notice on the device now, and I'll go ahead and accept. And then in the console, we'll get our native view of the device. This is view only. You notice up in the upper left-hand corner, the mode shows view only. It did say unattended if you were paying attention closely when we did unattended. So we have view, control, and unattended. So let's go ahead and leave this session. And let's do the last one, full control. We'll go ahead and launch remote help here. We'll get the notification. Now I'm going to go ahead and log in. Here's our notification. I'll zoom into that so you can see more details about what exactly it says. And then I'm going to go ahead and choose accept. And we'll get the audio notification again, and the screen is up. Now we're in mode full control. So if I want to launch the Play Store, I can launch that. I can go back to the main screen. I can pull up a list of running applications. You'll see I have full control of the device. Exactly the same as you have full control in unattended mode. You just see the difference there is that you've got no requirement for accepting your remote session. I'll go ahead and leave, and that's Android Remote Help. Let's take a look at a typical Windows Remote Help session. I'm logged in as Kelly, one of the support engineers, and you'll notice we've got a system that is not compliant, and this is Carrie. And Carrie's called over and logged a ticket. She's having some difficulty. So let's see what we can do to help Carrie out. We'll view the information about Carrie's laptop. And we'll start a remote help session. We'll do new remote assistance session and launch remote help. Remote help comes up, and because we're helping Carrie, we're going to do give help and get a security code. Here's the security code, and I've got a 10-minute expiration window. So let's take a look over on Carrie's system, and Carrie's going to launch remote help. And since this is the first time that she's done it, she'll get a little privacy notice, accept the privacy information, and now she's prompted to enter the code. So we'll go ahead and type in the code and submit. And now the remote help session connects between both Kelly and Carrie. We'll go ahead and choose Take Full Control. And you notice over on Kelly's side, she gets a prompt to ask whether or not she wants to allow Kelly to take full control. We'll go ahead and choose Allow. Now we get a notice indicating that Carrie's device is not compliant, and that may be a security risk. So in this case, because Kelly, our support engineer, is helping resolve the compliance issue, we're going to go ahead and choose OK. Or if this was a concern for Kelly and she wasn't aware about the compliance, she would choose Leave. We'll go ahead and choose OK. Now you can see we have a remote screen. We're able to see Carrie's desktop, and we can go resolve the issue from here. That's our example of how to use remote help for Windows. Let's take a look at some updates that have been made on the troubleshooting side to help your support agents. We'll navigate over to troubleshooting, and you notice I'm on the preview. We've got a bunch of users here that I can select from. We'll go ahead and select Carrie. And you'll notice the first thing that we get is a nice little summary view of what's going on with Carrie. This is much easier than the vertical scrolling that we had before. So we can see she's got one device that's enrolled, one role that's assigned to her, got some errors going on with compliance. So we could navigate to a list of devices. These are the security groups that Carrie is a member of, policies that are deployed to her, applications that have been installed. Carrie doesn't have any right now. App protection policies, updates, no updates right now. Enrollment restrictions, we've got a couple default enrollment restrictions, and then diagnostics. So this view should be a lot easier for your support agents to navigate, and hopefully it makes a lot of sense for them. Now let's take a look at our ServiceNow integration. I've navigated to Tenant Administration. we'll go to Connectors and Tokens, and then ServiceNow Connector. You can see that the connector is currently enabled, and it has a last connection date timestamp. Going to the next control, we can either turn on or off the ability to exchange data with the ServiceNow instance. Obviously, this is currently turned on, and I've got some properties that define how I'm going to connect with ServiceNow. The specific ServiceNow instance host, the table that I'm retrieving incidents from, and the ServiceNow client app ID. I had previously created a client app in ServiceNow and copied over the app ID so that I could use it for my connection. I can test my connection at any time. Let's try it. I click Test Connection, get a logo, and a verification message saying that this account would like to connect to my ServiceNow instance. Go ahead and choose Allow, and you notice that the update for verification shows in the connection status. Now that we've configured the ServiceNow connector, let's see how to use it in the Troubleshooting blade. I'm here in Troubleshooting, and I'm going to go ahead and select one of my users, Chris Green. We have the updated summary view. You can see a bunch of different tabs across here, and if I scroll down, I can authenticate with ServiceNow. This will authenticate me as the help desk operator with ServiceNow. Go ahead and choose Allow. And now I see the number of incidents that are associated with Chris Green. I've also got a tab here, ServiceNow Incidents. We go ahead and select that. You'll see I get a list of all the incidents that are associated with Chris Green. In this case, he has one that says, issue with my PC not starting up correctly. You notice we have a couple of different columns, priority, impact, urgency, severity, and status, as well as the assignment group and the date and time that it was opened. I can select a couple of different columns. So in this case, caller is the only one that's not listed here, but I can turn on or off these columns in the list view as I need to. I can also, of course, refresh. And if I want to add some filters, depending on how many incidents we have shown, I can create some filters. Let's say, for example, I want only status equals new. I can apply that, and those are the ones that we'll see here. This is the view that we have of ServiceNow incidents in the Troubleshooting blade.
Hi, my name is Saurabh, and I am a product manager with the Universal Print team. Phil and I will cover some tips to investigate print job failures. Let's do a quick overview of a print job's journey. The journey begins from a client that user prints from. It can be Windows, a cloud application like OneDrive, Excel, or any other platform. It can be your own custom line of business application that integrates print through Microsoft Graph APIs. Next up is Universal Print Service, hosted in Azure. A print admin can see jobs flowing for a printer on the Universal Print portal. A job processed successfully in the service would show up as pending in the printer's jobs view on the portal. Last two are the Universal Print Connector and the printer. Connector is a proxy that communicates with the service on behalf of the printer. It talks to the service using IPP protocol over HTTPS and to the printer using traditional print model. Universal Print Ready Printer does not need a connector and provides smoothest deployment as it communicates with the service directly. Once the job is in pending state, printer or connector will be notified by the service that there is a new job to print. Rest of the work to print needs to be done on the printer side. Service just waits. Today, we will focus on connector. Connector may have multiple printers and can process jobs for them in parallel. For one printer though, it processes one job at a time. For a busy printer, there may be multiple jobs queued up in the service. These all will show up in the portal as pending at the same time. Once connector starts processing a job, its status is marked as processing. Only after the job is completed, connector picks the next job. Looking at the job state, you can identify how far has a job reached in the print journey. Let's understand connector a bit more. Connector, at the time of registering a printer, creates a notification channel with the service. This channel is used to deliver notifications whenever there is a new job for that printer in the cloud queue. Every printer has its own notification channel set up by the connector. Once connector receives notifications on the printer's channel, and if the printer is ready, connector will fetch the job from the service. Then it calls a Windows API that renders a job using printer's driver and sends the print payload to the Windows print spooler. From here onwards, print job is processed like any other job will be processed by the spooler. Spooler forwards a job to the printer's port and it's off to the printer. Upon completion of the job, printer updates print spooler, which updates the connector. Connector further updates the job state in Universal Print Service. Client gets the job status from the service. Windows specifically removes the job from the local print queue upon successful completion. Printer is now idle again, and connector can process the next job on that printer. With that, over to Phil.
Hello, my name is Phil, and I am the CSS support lead for Universal Print. Now let's jump into some troubleshooting. Let's start by looking at the printer and its jobs in the Universal portal. You may want to investigate jobs that users report have not completed, like the one here, which is still in a processing state. The first thing we're going to want to do is go to the connector machine and look at the event viewer. Open the Windows Event Viewer on the connector host. Go to Application and Service Logs, Microsoft, Windows, Print Connector, Operational Node. To check events associated with a given job ID, click on the Find option in the right panel, put the job ID that you got from the portal, click on Find Next to navigate to job-specific logs. Continue clicking Find Next will help you navigate through the event logs for this particular job. One of the earliest logs for this job will be the Get Print Jobs request with event ID 3. This is when the connector got to know about the job and request information about it from the service. A later log with event ID 25 will show when the job started. Connector sends the job to the Windows Print Spooler, which generates a spooler job ID. You see that in event 10, spooler job ID is different than the Universal Print job ID. Spooler returns status as spooling under event ID 102. And finally, there's another log with event ID 102 that indicated that this job completed. We captured this log after we saw that the print state in the Universal Print portal as processing. Navigating through event logs of a job, if a job fails, it will have a corresponding error code from the spooler. You may search in public documentation about that error code and how it can be resolved. Next, we can investigate by looking at Print Management Console on a connector host. Open the Print Management Console. Check if the printer is in an error state. When it is in this error state, jobs from Universal Print will not get processed for that printer. You can also look at Jobs in Queue column. If there are many jobs in the queue, then the queue may be stuck. Effectively, connector will not download more jobs from the service. You can try fixing the printer error and fix the reason for the jobs building up in the queue to return the printer to a healthy state in universal print. For multiple jobs in a queue, you may look at the print-specific processes that are currently running on the connector host. Open Task Manager. Under Processes, there may be 2 transient processes launched by Print Spooler for printing the job. If printing appears stuck, then you can try ending these processes to resume the jobs. These processes will start again automatically when jobs start getting processed. High memory usage by any of these processes may indicate a driver leak. You may consider replacing this driver if it happens too often. With that, we come to an end for now. Thank you for watching the video. We'd love to hear your feedback. Reach out to us on Community. And don't forget to fill out a short survey to help us understand what you expect from universal print troubleshooting.
Are you an IT administrator using Microsoft Endpoint Configuration Manager? Have you wished for the day when Configuration Manager would be able to provide notifications and an experience similar to what your end users see on their home devices? Well then, I have something very exciting for you. Today we are announcing the ability for IT admins using Configuration Manager to leverage native Windows inbox capabilities for both orchestration and user experience on Windows 11 devices. Let's check it out. You probably recognize this as your typical Configuration Manager management portal. From here, you're going to go to Default Setting, then to Computer Restart. You'll notice a new option to select the restart experience to be shown to end users. Here, you will switch from Configuration Manager to Windows Native. Additionally, you can set a deadline in days for when the restart needs to happen by the same experience as a Windows Update for Business Managed device with compliance deadline configured. Note that all of your typical configurations and client policy, software updates, and computer agent will still apply. Additionally, just like with Configuration Manager today, you will be able to customize your organization name. Simply go to Default Settings, Computer Restart, and then enter your organization name. Then, simply set up a deployment and deploy. Your end users will now have the native inbox experience. Let's take a look. Once the update gets to their device, they will see the pending restart notification, letting them know that there is an update that requires a restart. If they go to the settings page, they will see an update from, in this case, Aria and Bruno Corp is pending. They will then see the option to schedule a restart, restart now, or restart tonight. Note, by changing the restart experience from Configuration Manager to Windows Native, your updates can take full advantage of active hours and other great built-in update orchestration benefits that come with the native experience. Interested? Don't worry, this feature is coming soon to an upcoming release of Configuration Manager. Until then, you can test it out today as part of the Configuration Manager preview.
Hello, my name is Thad Martin, and I'm on the Edge Distribution Services team at Microsoft. Today I'd like to talk to you about some new Windows Update functionality that is currently in preview for customers who manage updates in Microsoft Endpoint Configuration Manager or Windows Server Update Services, also known as WSUS. This new functionality is part of the Unified Update Platform, or UUP. There are several new capabilities with UUP. Today I'd like to focus on the ability for UUP updates to automatically retain installed optional features and language packs during Windows OS upgrades. As you are preparing to deploy Windows OS upgrades in your environment, if you have any users who have installed language packs or features on demand, you will want to make sure that that content is migrated through the upgrade so that after the upgrade, those things are still installed. Today, there are several options for ensuring that installed optional content, such as language packs and features on demand, are migrated through a Windows OS upgrade. These options either require that the endpoint computer be connected to the internet and allowed to download the content directly from Windows Update, or that the IT admin takes steps to ensure that the content is available during the upgrade process. Now with UUP updates, there isn't any additional work required other than deploying a feature update. When you deploy a UUP feature update, it will automatically ensure that all installed language packs and features on demand will be automatically migrated. To demonstrate this, my colleague Krishna will walk you through this process.
I'm here to show the demo for UUP update on this machine, which is running Windows 10 operating system. The version is 21H2, which we can see it in this about page. We can also check the language settings, what it is installed in this system. We can see we have English and French languages are installed as a preferred languages. We can also check the optional features which is installed in this system. It starts from Internet Explorer, Math Recognizer, Microsoft Paint, and so on. This is my configuration manager. I am currently in feature update page. We can see a lot of UUP updates. I'm going to deploy UUP update 2022-9C. I'm coming back to my machine now and going to install the software update. We can see the software update is available in my software center. I'm going to install now. We can see the download is in progress. Download is so fast, so I have clipped the video to not take more time here, and the update is installing now. I'm going to restart the system after update installation. It will take some time for restart. My system restarted successfully after UUP update installation. Let's check the Windows version. It is Windows 11. We can also check the language settings. We can see the languages are preserved after the update. Let's go to optional features. We can see the feature on demands are also preserved here. So summary, I have upgraded my system from 21H2 to 2022 without losing any of the feature on demand and language packs. Thank you.
Thanks for that great demo, Krishna. I would now like to review supported platforms for UUP updates. Any supported version of WSUS will support UUP updates. For Configuration Manager, the minimum version required is 2111, but at least version 2203 is preferred. For endpoint clients, we support feature updates to Windows 11 from Windows 10 version 20H1 or later. And for quality updates, we support endpoint clients that are on Windows 11. We are currently in preview with UUP updates and would love to have you participate in the preview to give us early feedback and to prepare for the general release of UUP updates in early 2023. To learn more, go to aka.ms/UUP preview. Thank you.
To all of the IT admins who have been requesting the ability to have your organization name show up in Windows Update notifications, you have been heard. Coming soon, your Azure Active Directory tenant name will be displayed. not just in the Windows Autopilot experience, but now in Windows Update notifications themselves. Check it out. Here is a device with compliance deadlines configured that is managed by Bruno and Aria Corp. Previously, their end users got notifications that said your organization, as in your organization requires that you update. Now, these notifications call out that it is Bruno and Aria Corp that require the action. Even better, when their end users go to the settings page, they'll see updates pending from Bruno and Aria Corp. This change helps provide a better end user experience and is coming soon to a Windows 11 device near you.
Hey everyone, my name is Ashwin Balika, and I'm a product manager on the enterprise and security team, driving some of the hardware security initiatives such as Pluton here at Microsoft. Pluton is a new security processor architecture which is built directly into the CPU. We collaborated with our silicon and OEM partners to ship devices with Pluton processors. Pluton is tightly integrated with Windows and Windows Update for better end-to-end scenario quality and to ensure that your devices receive timely and reliable security updates. Additionally, since this is built directly into the CPU SoC, it helps protect against attacks, especially in cases where malicious actors have physical access to the device. Currently, Pluton is offered on certain Lenovo and Acer systems. In this demo, I'm going to show you how to enable Pluton as a trusted platform module on these devices and verify that it's been enabled from within the OS. So let's get right into it. I'm now on a Lenovo ThinkPad system. The first step is to enter the BIOS screen, and in the BIOS menu, navigate to the Security tab. Select the Security chip option and make sure that Pluton has been selected as the security chip. Once this is done, you can save your changes and exit to initiate a system restart. The second device I'm showcasing is an Acer TravelMate laptop. Again, enter the BIOS screen, navigate to the Security tab, and ensure that Pluton has been selected as the TPM type. Once this is done, save your changes and initiate the system restart once again. Now that we've enabled Pluton from within the BIOS, how do we verify that Pluton is being used by the OS? It's a fairly straightforward process. In the search bar, type Security Processor, select the option. Under the specifications section on this page, the manufacturer will be listed as Microsoft, which means that Pluton is being used by the OS as the security processor. I'd also like to call out that both these devices are Secured-Core PCs which are built on top of Pluton, which protect your devices from hardware, firmware, and OS level threats. So that concludes my demo. We invite you, the customers, to evaluate Pluton, share your feedback, and if it meets your needs, deploy the solution in your environment over time. Thank you and have a great rest of your day.
Hello, my name is Jay Simmons. I'm a software engineer at Microsoft. I work in the Active Directory team located here in Redmond, Washington. We've been working hard to build a new version of the product known as Local Administrator Password Solution, aka LAPS. In this video, I'm going to demo some of the new LAPS features for the on-premise Active Directory environment. If you haven't yet seen the LAPS deep dive video, I recommend that you take a look at that first to get some additional background. Now on the screen you can see we have two virtual machines. On the left is the domain controller for our test domain, and on the right is a domain join client. The domain join client is actually running a server SKU, but all of the features I'm about to demo behave identically as well for client SKUs. Finally, while I want to note that while these two virtual machines are running internal builds, everything you're about to see here today can be demoed using publicly available Windows 11 Insider client and server SKUs. Alright, so the first thing we're going to do is we're going to extend the Active Directory schema with the new LAPS schema. And this is done just like in Legacy LAPS with a PowerShell commandlet. And by default it'll prompt us one by one for each of the things it wants to add. And that worked. And if we run it again, we can see that it's nothing left to do there. And we're now going to create a new container, or OU rather, for our demo. And we're going to move our domain join client machine into that OU. And now we're going to create a policy. Actually, before I create the policy, just like in Legacy Labs, the ability of the domain join client machine to update its password in Active Directory depends on the appropriate ACLs being applied so that it has self permissions. And as you can see in this new Labs PowerShell module, all the names of the commandlets have changed to avoid conflict. But the meanings of them are roughly the same. So in this case, we're going to choose this commandlet. And that worked. Now we're going to create a policy so that we can configure the client. And just one moment, I'll drill down here and find it. There we are. As you can tell, there's quite a few additional settings we have here. I'll be going through the majority of these either in this video, this demo, or other demos. But first things first, we have to tell the client which directory its password is going to be persisted in. And with this new version of Labs, if your client machines are joined to Azure Active Directory, we could go there. But for this demo, we're focusing on Active Directory, so we're going to choose that. And let's tweak the password settings, and let's say that we want a 32-character long password and a 7-day long password expiry. We're going to choose a custom local account, so we'll just make something up here. And there's a new feature, post-authentication actions. Now, I'll talk about this a little bit later, but for the moment, we're going to essentially disable this feature so that it doesn't interfere with our demo. Now, so we have the policy created, it's linked to the container, and the only thing left to do is we now need to go create that local user on the managed device. Labs does not do this for you. Now in our production environment, of course, you would either bake the local account into your deployment images, or you would use one of the various policy mechanisms to create it on demand. And last but not least, we're going to add that account to the administrators group. All right, so we're all ready to go. Now everything in Labs on the managed devices is tracked via event log messages, and so you can see there's nothing in here just yet. So we're going to now refresh the policy, and we should see some activity in the event log that tells us what was going on. Looks like there's something. All right, we'll refresh the event log viewer, and let's go to the bottom. And we'll walk through these events, and this is all done in a background task, and it's very human readable and easy to understand. So we're starting to process the policy. There's a dump of the entire policy that was in effect at the time that the task ran. So we can see that we got our policy from the policy came from group policy. We're backing up to Azure Active Directory, the name of the local admin account. Here's our modified password age and days. We didn't specify this in the policy, so it defaulted to the most complex version. Longer password. This defaults to on as well. We're not using password encryption or anything else yet, so that's good. We're going to Active Directory. Tells us why we're here, because group policy notified us that something changed. Tells us which DC that it's about to use, and gives us, it will give you some indications of why the password needs to be updated. In this case, there's multiple reasons, but the big one is that it can tell that the computer account does not have a current password expiration attribute. We updated it with the password, and it tells us what the account name was and the RID was, and we're done. All right, so we all know that the whole point of Laps is to actually use that local admin account for logon purposes. So I'm going to go back over here to the domain controller, and there are two password retrieval PowerShell commandlets. One is for the Active Directory scenario, and one is for the AAD or Azure Active Directory scenario. Obviously, we're doing the Active Directory scenario here. And there's a whole bunch of stuff here, but and some of it doesn't apply. Now, you have to remember that we are using the basic Laps feature here, and we did not turn on password encryption, so that means that we did not encrypt the password. So before we retrieve the password via the commandlet, let's just go take a look and see what it looks like raw in the directory. And I'll zoom this up. And this is in our demo OU. And here's our client. Actually, let me just do that again. All right, so I just want to show that the client updated the computer account with the following data. Now, you'll notice this is not simply just a clear text password like it used to be in Legacy Laps. We have actually a JSON string stored in this attribute. Right now there are 3 elements that can appear. We have an N for the name of the account, T is update time, and P is for the clear text password. The new password expiration timestamp here is, just like before in Legacy Labs, a 64-bit UTC time. Now let's retrieve that using our PowerShell commandlet. And you can see that we have a lot of nice information formatted. Name of the client, where it was located, the local account name. The password by default is returned in a secure string. Password update time, when the client updated it, when we expect it to expire. Now in this case it's 7 days after the update, because that's how we configured it to be. It gives you a source field. Now what this does is it tells you what type of attribute the password was stored on the computer object in Active Directory. So here we can clearly see that the attribute was stored in the clear text password attribute. Normally we would want to apply ACLs to control who can read and write it. I didn't apply any of those, which means that really it's just domain admins can do that, but I'm logged in here locally to this domain controller as a domain admin. These last 2 fields are relevant for password encryption scenarios, and I'll get to that. So let's do this. Let's say we want to get the password in total clear text, and there it is. All right, so let's verify that that actually works. So I'm not going to take the time to do a full-on interactive logon, but instead we're just going to run a simple run as command over here on the domain join client. Now I'm going to cut and paste this password from the domain controller on the left, and let me just bring up a notepad file to make sure that I have it pasted. Yes. Alright, so now we're going to run the run as command. I'm going to right click and paste the password, hit return, and there we are. So that worked. Alright, so let's bring up the ADAC. Let's bring up the ADUC, Active Directory Users and Computers snap-in. And let's go look at this domain join client device. You'll see over here in the ADUC property page for computers, there is a new labs property page. And if you look over here, The expiration time is not about 9:30 in the morning on the 1st of October. Same here. And we have the account name, and we have the local admin password. We could either copy it or we could show it if we wanted. In this case, what we're going to do now is we're going to mark this as expired. Now, this works identically to how it worked in Legacy Labs. We're just going to be modifying the expiry timestamp on the computer object in Active Directory. So let's do that now, and we're going to say OK. And for fun, let's go over here and take a look, and you'll see that, yep, it just got updated. So going back to the managed client. Now, we could rerun the group policy update, and that would cause our client to get notified. It would query Active Directory, and it would do the necessary update since the password is now considered expired. But I did want to point out one other little nice trick, which is that you can use the invoke lapse policy processing commandlet to manually update just the lapse policy. So we're going to run that, and we're going to go back to the event viewer, and you can see we've got some new events here. And let's see what we did here. So we woke up. You'll see that nothing changed in the policy, and we're configured to go to Active Directory. We're processing the policy because of an administrator request. In other words, that was because we ran this commandlet over here in this window. And then we're using that domain controller. And we need to update our password because the current password has expired. That's because we just expired it over on the domain controller. We updated it. Same stuff there. It worked. Great. So let's go back over here. Go to the lapse property page, and you can see that the current lapse expiration is now a week out from 9:35, just a minute past there. And if we show the password, it's now different than it was before. I can go back to the PowerShell window, and I can also run it there. And you can see that the timestamps have slightly changed, and the password is now different. One more thing. The reset lapse password commandlet is locally available on managed devices. You can also invoke it over a properly authenticated remote PowerShell session. And what this will do is it will tell the local lapse client on the managed device, reset the password right now. I don't care about anything such as password expiry. So we'll hit F5 here. We'll go down. By the way, just a tip. When you're looking for the beginning of a processing cycle, look for the 10,003 event. That's where we always start. So same basic policy, nothing changed there. We're going to Active Directory. It's basically telling us, hey, I'm updating the password because you told me to. Tells you the domain controller. Updated the password. Done. Done. We'll go back over here and we'll get the rerun this. And you can see that we have yet again a slightly new password with updated timestamps. Ta-da. All right, well, that was fun. All right, so we're going to clear this event log just so it doesn't get too cluttered. Now, I want to talk a little bit about password encryptions. Password encryption is something that many of our customers have been asking us for. And we do have it in this version of Lapse. Now, the way you do that is that you, for the managed device, you modify its policy here so that it is enabled, so that password encryption is enabled. And under the covers, we're using Active Directory Data Protection API, DP API, and we're using the particular DP API mode that where you are encrypting a buffer against a particular Active Directory user or group, so that only that particular user or group can subsequently decrypt the buffer. So if we do allow you to specify who the user or group is that is allowed to decrypt it. Now in this case, if you don't specify it, we always will default to the domain admins group of the managed devices domain. So I'm going to not specify that here for a moment. and we're going to, we've just modified the policy. Password encryption is enabled, and we're going to reapply the policy to the device. And once that completes, we should be able to go in the event log and see that the client switched over to using encrypted password encryption. All right, so let's go take a look here. Where's the event viewer? And we'll hit refresh. Uh-oh, we've got errors in the event log. Well, let's follow along here and see if it'll tell us what actually happened. So we're starting. That was at our, again, this is with the 10,003 event. Policy dump. Now we should see a change here, and we do. Notice that the password encryption is now enabled, but the target principal, that's the user that would be able to decrypt the password, is not specified. So the device will choose the domain admins group. We're going to Active Directory. We're processing the policy because GPO told us to, using that domain controller, and it's telling us that we're supposed to be using password encryption, but we couldn't find the password attribute in AD. Uh-oh, there is an error. Okay, what does it say? Lapse password encryption is required, but the AD domain is not yet at 2016 DFL. Blah, blah. And then that's just another summary. Tells us that we failed to update. Now, I did mention this briefly. I might have mentioned this briefly in passing. So the new lapse password encryption feature requires 2016 DFL or higher. Now, there currently is no higher, but there could be. But this is not an arbitrary restriction. There was some under the covers behavior changes in some of the encryption logic, such that when you have a domain with a mix of 2016 and higher and 2012 R2 and below domain controllers, sometimes decryption does not work. Now, for that reason, to totally avoid surprises and to make sure that everything behaves the way it should, this feature has a hard requirement. Password encryption has a hard requirement on Windows Server 2016 domain functional level. And, this is the year 2022, so it's time to get off those 2012 domain controllers anyway. So let's go raise the domain functional level. And we're going to go to 2016 and we're going to raise. Yes. All right. Now we're going to go back over here to the managed client. Now the policy has not changed on the managed client. It still wants to encrypt its passwords. It's just it was blocked before because the DFL was not yet at the required minimum. So we're going to rerun that policy processing command. This is a little, like I said, a more scoped version that allows us to skip GP update. So let's try that. And it worked, or it looked like it worked, but let's go to the event log. So we'll find the 10,003 event. Same, no changes to our policy. Going to Active Directory, doing it because we told it to. That DC. Same reasons why it still knows the same reasons why it needs to update. Updated it with the password. Awesome. So because password encryption is enabled, that means that it encrypted the password on the client device prior to storing it in Active Directory. And then the rest of it is the same. So I want to go over here and let's refresh this query. You'll notice, now I want to scroll up here and take a look at what was here before. Before we had the clear text version of the password along with the password expiration time. And now we have a binary blob in a different attribute, mslapse-encrypted password, and the encryption, the password expiration time has been updated. So the device recognized, the managed device recognized that it's the policy configuration had changed. It encrypted the new password, stored it on this attribute, updated the password expiration time because it was updating the password, and finally it deleted the previously set clear text attribute as well. Okay, so let's retrieve that same command, and you can see that most of this information has not changed. Same managed device, same local account. Here's our new clear text password. Now keep in mind that it was encrypted in the directory, and the PowerShell commandlet retrieved it from Active Directory and then decrypted it on this machine, on the domain controller, before displaying it. Updated expiration timestamp, tells you where we got it from, tells you that, yep, we were successful in decrypting this buffer. And this is a nice little feature, and I'll show this a little bit later. This field tells you who is the entity that is authorized to decrypt the encrypted buffer. And this, if you can query the encrypted buffer, the way that the underlying under the covers DP API format works is that you can retrieve this information even if you don't have permission to decrypt the buffer. So for situations where you're trying to figure out just who the heck is supposed to be able to decrypt a particular encrypted password, this field will tell you that. All right, so we're going to go back to the managed client here. And I want to copy this clear text password, make sure it's there, and we're going to rerun the run as command. I'm going to right click and paste in the password, and there we are. And I want to point out that expiry of the password via the expiration timestamp in Active Directory works identical regardless of whether the password is being stored in clear text or in encrypted format. So there is a set expiration time commandlet, and what this does is it says, okay, for the identified target computers, please set it. Let's see here. So we're going to set this to all right, you'll notice that previously we had a expiration timestamp that was like a week out, and now it is right now. So now we're going to re-invoke the policy, and then we're going to rerun this. And there we are. We've got a brand new password, and the device correctly noticed that it had been that it was expired. And so that scenario works the same regardless of the format in which the password is stored. Let's go back to our policy. I want to talk a little bit about password history. Many customers have asked for this feature. This is useful in cases where you're restoring a device from an older backup media, a backup image, and let's say that you're unable to access that device after you've restored it, and you want to use the local admin account password to do that. Well, if you were only storing the very latest password in the directory, then it's very possible, like if your backup media is months old, that the password that was in effect when the backup media was created is no longer matching what's in the directory. So if you have configured your lapse policy to use encrypted passwords, you now have the option of enabling password history. And this goes from a minimum of 0, that's basically disabled, up to a maximum of 12. And so I should just briefly mention, so why does this feature require encrypted passwords? Very simple reason. For the device is not, there's no lapse specific logic on the domain controller here that is assisting the managed client in maintaining the history. The way that the client maintains the history is that it has to read the older version of the password from Active Directory, save a new one in the primary attribute, and then take the n-1 attribute and put it in the history attribute. And I'll show you what that means here in just a second. But essentially it requires that the client have permission to read the encrypted password. For this feature to work for clear text passwords, it would require that the client have permission to read the clear text password, and we don't want to do that. That's not a good idea. So I'm going to save this policy, and we're going to update the policy GP update refresh on our target device. And I'm just going to scope this down so it's just the computer. And once this completes, we should see Let's see what we see. I want Event Viewer. All right, we start at 10,003. We're starting. Here's our new policy. You can see that we now have a password encryption history size of configured of 12. Going to Active Directory. We're here because of a GPO notification, that domain controller, and we don't need to update it. So we enabled password history, but the current password is perfectly fine and has not yet expired. So, there's no reason for us to update the history unless and until we're required to update the password. And so we're done. All right, so that was kind of, that was logical. That's what we would expect, but it was also kind of boring. So if you remember, we have the reset lapse password. So let's do that. Let's tell the device, reset the darn password right now. And we'll go look back in the event viewer, starting at 10,003. Starting, I know this gets old, but I'm just trying to help you guys understand the flow here and what to look for. Same policy, no policy change. We're updating the password because an admin told us to. We updated it. Same account. All right, so let's go take a look over here, and we'll rerun this, and we can see that the password did change. We have an updated password expiration timestamp. Now let's take a look at a new parameter on this commandlet, include history. And you can see here now what this does is it displays these in order from newest to oldest. So the first one displayed is always the most current one, and it has the current one is the only one that has an associated expiration timestamp. Now here is our N-1 password that is there because we've now configured password history. It doesn't have a password expiration timestamp, but it's there, and you can see from the source that it came from a different attribute. And so let's just convert all those to plain text as well. There we go. So I do want to point out that it's possible if you change the policy over time based on who can decrypt the password, that when you run the commandlet this way, that let's say for a target computer that has a large number of passwords in the password history, that some of them might be decryptable and some of them might not be. Now there's nothing wrong with that. This just it can happen, and I don't think you'd see that in a real production environment, because I imagine you're going to settle down pretty quickly on a common decryption group or something. But I just wanted to point that out. All right, so let's take a look. Now, I am logged into the managed device on the right as the domain administrator. Now, nothing I've done here on the client device depends on that. I could have been a local administrator as well. So let's try something here. I'm going to clear this event log just so it's a little less cluttered. And we're going to go modify the policy by creating a new group. So let's try this. Oh, before we go there, let's just take a look at our using ADUC. Let's take a look at the lapse property page. And I just want to show that we're storing encrypted passwords in the directory now, and even so, I'm still able to get the latest password. So it's BK blah blah and BK blah blah. Note that the user interface in ADUC does not support displaying the historical passwords. It's not envisioned that you're going to have to go back in time and look at the previous passwords on a very regular basis. So when you do need to do that, you'll have to resort to using the PowerShell commandlet. All right, so let's create a new group. Where is it? And we will call this the lapse password admins group. And we're now going to go to our policy, and we're going to configure this policy. Now this is the policy where if you want to, you can specify a custom user or group that you want to be able to decrypt the given passwords that are encrypted under this policy. And you can only enter one. It could be a user or group, but I highly recommend that you use a group. The way I would normally suggest doing this is that you create a, you have to decide for the sensitivity of the devices being managed, whether you can use a common decryption privileged identity for all of those machines, or if you need to segregate them, which of course would require different policies. In our demo situation here, it's very simple. We're just going to have a single group here. And so we're going to say OK. And we're going to refresh the policy. And let's go take a look on our event log. Alright, so we're starting, and you'll see here that we have the device now has the new target principal for decryption of the password. Going to Active Directory, GPO notification, using that DC. We try to be careful about updating the password. So if for some reason you change who the authorized decryptor should be, that's treated as a sufficient cause for us to update the password immediately, regardless of password expiry. So we updated the password, and that's the same. It worked good. All right. So let's do the following. So let's we don't want history this time, but let's just retrieve that that password. Oh, look at what happened. Okay, so you can see that we got that information, so it could see the client, the computer object for the managed device in the directory, and it could read this information, but it couldn't get the account name or the password because we are unauthorized. Now I'm logged in here as a domain admin, but of course we are not a member of this group. So let's go fix that. Lapse, password admins, and we want to say members. We're going to add, let's see, is it administrators or domain admins? See if that works. Still didn't work. Well, that's not fair. I think we have, now you have to remember that the authorization decision for whether you can decrypt the blob or not depends upon the SIDS in your token. So if you make a change like what I just did, a dynamic change to the membership of the group that's authorized to do the decryption, in some cases you may want to purge your tickets. Now, I can't remember if this is going to work. I'm still unauthorized. I think I'd have to log out. So rather than do that, I'm going to run this commandlet from over here. Now remember, I'm logged in on the left as, on the right rather, as the domain administrator. So let's just run this. And it didn't work. And again, this is also due to the same reason. The cache tickets I have on the managed device on the right don't have that SID in the token. And you can see that after purging tickets here, I now was able to decrypt the password. So I was able to decrypt it, I was able to get the latest one, and it also told me, it still tells me who the authorized decryptor is. Alright, so there's one more demo that I kind of want to give here. And let's create a second group. So lapse, password admins doomed. You'll see what I mean by that in a moment. All right. Members, add. So we have this doomed group, haha, and we're going to make domain admins a member of it. Okay, so what I'm going to do now is I'm going to reset the password arbitrarily. And now I want to retrieve it over here. Oh, what happened there? Let's check our event viewer. See, 9:58, it did update. Oh, let's follow along. This is a little bit of good debugging. So you'll notice that I forgot to update the policy on the managed client. So it still thinks it's encrypting it here. So let's just fix that. Wait for that to finish. And now this time we should see the new group. No, we did. Oh, because I forgot. Okay, so I created the new group, but I didn't modify the policy. So you're getting to see a little bit of demo dumbness as what combined with troubleshooting here. So we're going to fix this. There we go. Save the policy. Close that. I'm going to clear the event log just to clear things up and make it clear what's going on. We're going to refresh the policy on the managed client. All right, let's take a look. So we updated the policy. There we go. There's our new group. Configured update, processing, DC. We're going to force the clients arbitrarily deciding to update the password again because we've changed the encryption target and updated it. Good. So let's just take a look over here. And now again, I know this may be confusing in a demo situation where the same problem exists. I would have to log out and log back in here for this to work, and I don't want to do that. So, but the point of this demo that I'm doing right now is I want to show you what happens if we now delete the security group that was authorized to decrypt that password. Now there are some tricks in Active Directory where you can restore deleted users and groups using from the Active Directory recycle bin and tricks like that. But if you were to, it's possible that you might get into a situation where you're trying to retrieve a password, say for very old media, and that was created, say 8, 9, 10 months ago, and the group or user that the password had been encrypted against no longer exists. And in fact, because the tombstone lifetime has been exceeded, that user or group can no longer be restored. And the decryption operation depends on being authorized as having the specific SID of that user or group in your token. But that user or group is gone permanently. It cannot be recreated. So when we thought about this problem, we were like, okay, what we did to solve this problem is that we were providing a special mode in the password retrieval commandlet. And we call this, let me show it to you here, we call this recovery mode. Now, there are some restrictions here with recovery mode. You can only use recovery mode when logged in locally to a domain controller. So this is not meant to be something that is used all of the time. It does work with history if you want to use it that way. And for the most part, it works pretty much identically to the normal mode. But you do have to run it locally on the domain controller. So we're going to go, and we want as plain text, and we want recovery mode. And you'll see that we were able to retrieve it. Now in this case you can tell, okay, so we got the password and got everything else that we normally get. It came from in the encrypted password. We were able to decrypt it, but that's mainly because we were using recovery mode. And in this case, it remembers what we can retrieve the SID of the authorized decryptor from the DP API buffer, but it's not resolvable anymore because we deleted the group. So let's just double check that the password retrieved via recovery mode is actually usable. I'm going to paste in this password, and there it is. All right. So this has been a little bit of a whirlwind demo, but I hope you can tell that there's a swath of new features here that are very useful. I know that most of the focus for the new Laps feature is on the Azure Active Directory features, but we also realize that many of our customers will be running in a hybrid environment for many years to come. And for that reason, we really tried hard to cater to a all of the above approach. So if you want to move completely to the cloud, that is an awesome idea. If for whatever reason you're limited to staying in a hybrid environment with Active Directory domain join clients, you now have a brand new option with a lot of new security and usability benefits that'll let you keep using that'll make Laps a much better feature in your environment. So in this demo, we've demoed a lot of things related to the on-premise Laps feature. I highly recommend, or I'm asking rather, that you try these out. Give us the feedback. We would love to hear it. Thank you very much. Hello, my name is Jay Simmons. I'm a software engineer at Microsoft. I work in the Active Directory team here in Redmond, Washington. We've been working hard to build a new version of the product known as Local Administrator Password Solution, aka Laps. In this video, I'm going to demo some of the new Laps features for on-premise Active Directory, and more specifically, I'll be demoing the features that are relating to domain controller DSRM accounts, or Directory Services Repair Mode accounts. If you have not yet seen the Laps deep dive video, I recommend you take a look at that first to get some additional background. Now on the screen we have two virtual machines. On the left is a domain controller for our test domain. On the right is a domain join client. The domain join client is actually running a server SKU, but all of the features I'm about to demo behave identically as well for client SKUs. Finally, I want to note that while these VMs are running internal builds, you can demo everything you see today using publicly available Windows 11 Insider client and server SKUs. So just a brief bit of information about DSRM. DSRM accounts are a recovery account that exists on every Active Directory domain controller, and they are used in the case of when you need to boot. They're used to log into the domain controller when booted into a special mode that allows you to log in with this. Now you can think of it conceptually as sort of a local account that's unique to every domain controller. Normally domain controllers don't have any notion of local accounts. The DSRM account is sort of a special case exception to that rule. So what have we done here with respect to Laps and DSRM accounts? What we've done is we've enabled the ability for domain controllers to be configured so that they regularly rotate their DSRM account passwords and store them in the directory. Now this uses the same Laps schema, the Laps schema attributes, the same Laps client, and much of the same policy configuration as you're about to see. So why would you want to use this? Well, for a lot of good reasons. If you are, we know many customers already have well-established IT practices around their DSRM accounts, but if you don't have such well-established practices, this gives you another option in your toolbox. For instance, the fact that these passwords will replicate means that from any domain controller, you'll be able to query the DSRM account for any other domain controller. So that's a very useful feature. You don't have to worry about having to remember it. The knowledge of the DSRM account passwords for every DC in the domain is replicated, and therefore it's redundantly stored. And they will be unique per DC, although I know that doesn't help much. If an attacker gets access to one DC, it's kind of over. So let's get into this demo here. So the first thing we're going to do is we're going to configure a new group policy for our domain controllers. And we're going to edit that. And if you've seen my other video on domain join clients, you've seen all this. Now, DSRM, lap support for DSRM depends on some very specific requirements. So you do need to choose Active Directory, period. And you must enable password encryption. Okay. And you also have to specify this one, which is enable password backup for DSRM accounts. Now, a domain join client will ignore this setting because it doesn't make sense for domain join clients. It only makes sense on domain controllers. So if you enable the lapse policy for domain controllers, this one must also be set. Now, I could have made that the default, but I wanted this to be a very explicit opt-in. So if you're going to be applying lapse to domain controllers in order to manage the DSRM account password, you have to set this policy. So now let's go take a look at the event viewer. And okay, so this is a previous one from prior. So we're going to clear the event log here and then refresh the policy. Clear. And when that's done, we should be able to go look in the event log. Alright, so now I see multiple 10,003 events, or at least 2 of them, so let's take a look and see what happened here. So gives us a policy dump, GPO, Active Directory. The local administrator account name policy is ignored for domain controllers because you can't control the name of the DSRM account. We left that to 30 days. Password length is 14. Password encryption is enabled. For target principal, I talked at length about this in the domain join client demo video. Domain controllers will only ever encrypt the DSRM account passwords so that domain administrators can decrypt them. So even if you were to configure the policy with something for this particular setting, it would be ignored. We have not configured password history size. Now this is where this is the new one that we set, the important one. Now, we left the post-authentication actions enabled, or set to their defaults, rather. But I do want to point out that this is a little misleading because even if these are set, whether to the defaults or to explicitly some actions, such actions are ignored whenever you log in with a DSRM account. You are logging in as a DSRM account on a domain controller. It doesn't get much more sensitive than that, so we don't feel the need to try to second guess your use of the password. So we're doing this in response to a GPO notification. We're using our local DC. Oh, we got a problem. Okay. So the Active Directory schema has not been updated with the necessary last attributes. So this is a little bit of a bug. This should really be a warning event, not a informational event. So we failed because the schema has been updated. I'm pretty sure that the events above here are going to say the same thing, but let's just take a quick look. Yeah, okay. So I'm going to clear this event log just to clear things up. And we're going to go back. We're going to okay, now as I showed in the other video, we have a schema update commandlet, and it doesn't really take any credentials. But what I did want to do, since we're about to do this for real again, is I wanted to show some of the verbose logging that is available. So let's take a look at that. So let me just pull this down. So many of the Active Directory related commandlets have nice verbose logging. So you can see here that it's telling you all kinds of good stuff, what domain we're joined to, activity around binding, information about the domain that we bound to. In this case, is looking for the schema master. So it has to go find that. Tells us which DC we found. Tells us which functional level that domain is at. More stuff about that, about the force and the domain, and now we're getting started. And it's now what this commandlet does is obviously it just looks for the necessary schema elements that should be there, and if they're not there, it asks us if we want to add them. So in this case, I'm going to suppress all of this by just saying all, so we don't have to be prompted at every one. And if you can see there that it's verbosely giving you lots and lots of detail about everything that it wanted to do. So if we run it again, it ran, but this time it didn't do anything because everything the schema was already updated. All right. Now we could update the policy again, but there is a separate commandlet that we can use to force the Labs client to rerun, to reprocess the policy, and this is a more limited way of doing this that is outside the scope of a full-fledged group policy update. So let's just run that. Oh, what happened there? Let's take a look. So your first option for whenever a failure occurs is to go to the event viewer. Let's take a look. Policy is now starting. Looks like no changes in our policy. So what happened? Configured to backup passwords Active Directory. We're doing it because of an admin request. It recognizes that it doesn't have the expiration attribute on the DSRM on the password in the directory on the domain controller account. We've got DSRM in mode where we didn't have it before. We're supposed to be backing up the DSRM password, but we didn't find it. Okay, another forgetful. So this is a case of the bug is behind the keyboard. We have a forgetful demo person. So just like with the domain join client video, password encryption, even for DSRM accounts, requires the domain to be at 2016 DFL. So now I'm going to clear the event log so we can have a fresh look at it next time around. And let's go raise the DFL. And we can clear that. Let's try it again. Oh, looked like we might have had some success there. Let's take a look. So we're starting. Same policy, back up the DSRM. Configured to backup passwords Active Directory, good. Processing needs to be updated. And this time it worked. That's awesome. And you'll notice it gets slightly different event details. On almost every Active Directory domain controller in the planet, you will see administrator here, but it could be different maybe if you originally created your domain with a different default locale. The DSRM account RID is always 500, but it's there anyway just in case. And we're done. All right, so let's... Now how do you retrieve this password for the DSRM account? So we're going to use the same GitLabs AD password retrieval, and we're just going to pass it the name of the domain controller. Alright, so you can see here that it's the domain controller account, and the domain controller is OU. It's the administrator. That's what DSRM accounts are named, as administrator usually. Cleared passwords wrapped up in a secure string by default. We have a 30-day expiration period. It's telling us that it came from the encrypted DSRM schema attribute. We're going to go look at that in a moment. We're able to decrypt it, and anyone in the domain admins group is able to decrypt it. So let's just go over here and request it as plain text. And you'll recall that we had a slightly shorter password. Let's see here. So what was our password set to? 8-character password length. We didn't configure any password settings. So it's an 8-character password length. All right, so that worked pretty good. Now let's go take a look at. It worked really good once we got past some of the kinks. So in the Active Directory users and computer snap-in, we can also use the new Labs property page to view DSRM account passwords. So if we take a look at this and we go to the Labs property page, you can see we have the expiration timestamp. We could expire it right now if we wanted to. We'll try that. It tells us that this is a DSRM account, and we can do a show. So you can see that here and here are identical. So let's try to expire that. Actually, that's good. Be a good test. So we go properties, lapse, expire now. Okay, and oops. So let's see what happened in the event log. So we're starting, no changes to the policy, backing up to Active Directory. We're processing the policy because we told it to. Same DC, and it's noticed that the password has expired in Active Directory, and we successfully updated it, and it's the DSRM password. And if we retrieve the password, you'll see that this is something here, and it's changed here. We've got slightly updated things. Let's go look at that in the directory via LDP. All right, so you can see here that in the DSRM scenario, we're still using the same password expiration timestamp attribute. In fact, that attribute is used for all three of the sub-scenarios, whether we're storing a clear text password or an encrypted password for a domain zone client, or if we're a domain controller that is storing an encrypted password for the local DSRM account. So just a quick look at that. Well, the proof is in the pudding, so let's just see if we can't use that to log into this domain controller using the DSRM account. So I'm going to retrieve the password over here on this client machine. All right, so we have that, and I'm going to now want to boot into DSRM mode. 1 second. All right. Here we go. So we're going to log in. Oh, we did not go into DSRM mode. Why did we not go into DSRM mode? Oh, there we go. Let's try that. Let's type our password in. Okay, there we go. It worked this time. And you can see that we've just booted into safe mode. And I want to retype in that, repaste the password that I used to log on. You can see it's the same one that we retrieved initially over here on the management client. And we're in safe mode with a password that was stored there by Lapse. So Like I said at the beginning of this video, I know that many of our customers already have well-established practices around the maintenance and the security of their DSRM passwords. This is another option in that toolbox. If you're still storing DSRM account passwords on sticky notepad, on notepad stickies, then this gives you a great out-of-the-box option that is just there and just works. Thank you for listening, and I hope you enjoyed the video.
Hello everyone, my name is Abraham Pineda and I'm a PM in the Windows 365 team. Today, I would like to show you a demo of the connectivity health checks and end user connectivity history report, which will go on public preview very soon. The connectivity health checks are a set of checks that continuously run in the backend to make sure that the cloud PC is in a healthy state and ready for the user to connect to. When the checks successfully pass, a user should be able to connect to the cloud PC. When any of these health checks fail, a user will lose connection to a session. When any of the health checks fail, helpdesk and endpoint computing admins will be able to run a troubleshooter tool that will help fix common issues within the cloud PC and allow users to regain connection to the session. Moreover, admins will also get a historical report to learn when a user lost connection to their cloud PC, what was the potential cause for the loss of connection, and a description of the error. In this report, admins can see the history of failed checks, but they can also see unexpected network errors and disconnects beyond what was captured by the connectivity health check. For example, a user unexpectedly losing connection due to an interruption from your ISP, or someone turning off the Wi-Fi router. So now I'd like to show you how this feature works. Here we are in the Windows 365 user portal. Here we can see that this user has two cloud PCs, one with 4 core and 16 gigs of RAM, and another one with 8 cores and 32 gigs of RAM. Let's try connecting to the 8 core cloud PC. As you can see, I was unable to connect to the cloud PC. Now, as an end user, my next step of action would be to reach out to my helpdesk admin to see if there's anything they can do to help me get back into my session. So let's go ahead and switch roles and pretend that I'm the helpdesk admin that's going to help troubleshoot this user's connection. Let's go ahead and navigate to the MEM console. Here, I've already searched for this user. So let's go ahead and click on them. And now we're in the device overview tab. Here, we've added this new tab called Performance. Let's dive a little deeper and see what we can find. So now here we can see the Cloud PC connectivity status tile. As you can see, this Cloud PC is in an unavailable status. Before we troubleshoot it, I'd like to dive a little deeper and understand what's the connectivity history of this user. Now, in this report, I can see the success and fail history of the connectivity health checks. Recall that whenever a connectivity health check fails, the user won't be able to connect to a cloud PC. As we can see here, the stack listener check failed recently. So now let's navigate back to that device and try to troubleshoot it. So now we can click on unavailable. And as we saw in the connectivity history report, the stack listener check failed, and therefore this user lost connection to a cloud PC. For this specific check, we make sure that the stack listener installed on the cloud PC is up and running. If it's not, then the user will lose connection to a cloud PC. So let's go ahead and click troubleshoot this connection. Now we wait while the troubleshooter tool runs a set of troubleshooting steps and VM extensions in the backend to get this VM up and running. It can take up to 20 minutes to complete, depending on the things that are failing within the cloud PC. If the admin needs to navigate away from the screen, they can do so while the troubleshooter runs in the background. When the troubleshooter is finished, the admin will get a notification in MEM. Now that the troubleshooter is done, I can see in the results that the issues have been resolved. So let's go ahead and close this. And now we can refresh this tab. Now here we can see that the Cloud PC connectivity status, it's available. So now we can contact the end user and tell them to try connecting to a Cloud PC again. Let's try doing that. Input the credentials, click sign in. And there it is. We've successfully troubleshooted this end user and now they can connect back to a Cloud PC. Thank you for watching this demo.
Windows Autopatch might indicate that some of your devices are not ready. To address the issues we found, select the Devices blade in Microsoft Endpoint Manager. Under Windows Autopatch, select Devices, and then select the Not Ready tab to see a list of devices that have failed the readiness or registration checks. Then, select the name of a device that has a failed status to see details about each error with a link to support information. Select the link to view step-by-step instructions for resolving the problem. When you've taken the necessary steps and your devices are all ready, you'll need to set up your test ring. For detailed instructions, see our video at aka.ms/autopatch test ring. For more how-to information about Autopatch, see aka.ms/autopatch. If your Windows Autopatch tenant readiness assessment comes back not ready, select View Details to review the outstanding issues. Then, select a specific entry to get instructions on how to resolve that issue. Once your tenant is ready, you can continue with your Windows Autopatch enrollment. For more how-to information about Autopatch, see aka.ms/autopatch.
Hello, my name is Jay Simmons. I'm a software engineer at Microsoft. I work in the Active Directory team here in Redmond, Washington. We've been working hard to build a new version of the product known as Local Administrator Password Solution, aka LAPS. In this video, I'm going to demo some of the new LAPS features for on-premise Active Directory, and more specifically, the features relating to legacy LAPS emulation support. If you have not yet seen the LAPS deep dive video, I do recommend that you take a look at that first to get some additional background. Now on the screen you can see we have two virtual machines. On the left is a domain controller for our test domain, and on the right is a domain join client. The domain join client is actually running a server SKU, but all of the features I'm about to demo behave identically as well for client SKUs. Finally, I want to note that while these virtual machines are running internal builds, you can demo everything you see today using publicly available Windows 11 Insider client and server SKUs. So first things first, we're going to install LAPS on the domain controller. Now I don't want the GPO extension on the domain controller, but I do want the management tools. Great. And And we're now going to create a new OU for our legacy lapse scenario. And I'm going to move our client into that new OU. All right, so next we're going to be see, we're going to refresh this, and we're going to create a new policy using the legacy lapse GPO. And let's edit that. So we're going to go Policies, Administrative Templates, and here it is. Now there could potentially be some confusion because of the fact that the new version of Lapse that is now built natively into Windows shares the exact same name. I confess to having to take the blame for that. I couldn't think of a better name, and so there is that little point of confusion. So as you can see here, we have the very well-known Legacy Lapse GPO settings. So let's start out with we're going to say enabled. We're going to enable the feature, and we're going to tweak the password settings and have a 32-character long password and a 7-day long expiry period. And we're going to use a custom local account. Now we'll just call it Lapse Admin. There we go. Say OK. And over here, we're going to create that new local account. Great. And we're going to add it to the local administrators group. All good. All right. So we have moved the managed client device on the right into a brand new OU, and we've installed the Legacy Lapse MSI package on the domain controller, and we're now going to apply that new Legacy Lapse GPO policy to the client. Now, as I've been mentioning in other videos, all lapse activity on the managed client is tracked in the event viewer. So we can go here and refresh, and this is the latest one. So if I look at this, let's just walk through this slowly and see what happened. We're starting. Tells us that there is a policy configured. We can tell that it came from the Legacy Lapse GPO, not the new Lapse GPO. By definition, we're going to Active Directory. Custom account name, 7-day age, password complexity was not specified but defaulted to 4, 32-character password, and we didn't touch this, so that defaulted as well. We're going to Active Directory. It's telling us that we are processing the policy in response to a GPO notification using that domain controller. And oh, I forgot. Okay, that we forgot to update the schema. So let me close this. We're going to clear. That should really be a warning event log message, not a informational. But let's clear this so we can see it better next time around. Now, Legacy Lapse came with its own PowerShell module. And you can see that if you've seen some of my other videos for the new built-in version of Lapse, there's a lot of similarities here. So first of all, we do want to update the schema. That's what the client was warning us about. And the other thing that I can see now that I forgot to do was to apply the self-permissions to the OU. And so let me just go back and look at what the name of that was, Legacy Lapse OU. Okay. So we could refresh the entire group policy, but because we're going to use the new Windows built-in Labs PowerShell module, and then more specifically, we're going to rerun the policy, just the Labs policy, using the invoke Labs policy processing commandlet. All right, that worked. We've got some new events in the event log. Let's see what happened. So we're starting. No changes to the policy, still coming from Legacy Labs. Backing up to AD. This time we're processing the policy because of an administrator request when we ran the invoke Labs policy processing commandlet, and not in response to a GPO notification. It tells us which domain controller we're going to be using, and gives us several reasons why we need to now update our password. And we've updated the password, and we turned around next and updated the local admin account, and that succeeded. So I want to fire up LDP so that we can go look at the actual new note, the changes in the directory directly. Don't worry, I'll zoom that up in a moment. And the Legacy Labs OU. Alright. So, as you can see here, what you have just seen is this stock Windows domain join client on the right responding to the Legacy Labs policy set by the Legacy Labs policy template. And I don't think there'll be any doubt here, but just to show that there's no tricks up my sleeve, we'll just go here into Programs, and you'll see that the Legacy Labs GPO CSE is not present, or at least not installed. I'm logged in as a domain administrator on the left, so I'm able to see the clear text password directly in the clear. So let's see what we can do with that now. So Alright, so this is the, now I could obviously copy the password directly from LDP, but where's the fun in that? Let's use the original management tool. So we're going to do a search, and it gave us the password. I'm going to copy that because I want to show that we really did do the right thing here, and that we really did store that password on the client device, the managed client. Alright, so I'm just being very cautious to make sure that I do have the password on the clipboard right now, so I'm just going to, yep, I do. Okay, good. Alright, so here we go. And I'm right clicking to paste that password, hit return. Oh, bad. What did I do there? Let's try that again. I think I pasted it twice there. So there we go. And so again, just to reiterate what just happened there, we have a bone stock Windows domain join client on the right that is being configured and administered using the Legacy Labs policy element. We are able to retrieve the password after it was set by the managed client in Windows. We were able to retrieve it using the Legacy Labs management UI, and then use it for an actual logon of the managed account. So let's try out the expiration functionality. So we're going to say that this expired back on the 14th, which was 10 days ago. So let's do a set, and I'm going to go look at it in LDP real quick, and you can see that this was, the password is now considered effectively 10 days expired. So we go back to our managed client, and I'm going to rerun the policy. Now we could do this with a GP update, and that would also run the background task, but this is a little bit faster for demo purposes and more scoped. We got some new events. Let's take a look. So we're starting. No changes in the policy. We're configured to backup passwords to Active Directory. Admin told us to do it using that DC. And we've noticed the inbox native Windows client, lapse client, has now said, okay, I'm configured by legacy lapse policy, so I now need to query this password expiry timestamp, and it correctly noticed that it's expired. And we updated it with a new password and did that, so that's all good. So if I requery an LDP, you'll see that a brand new different password has now been updated, and the new updated password expiration time reflects the 7 day from now interval. So you can continue to use, if you're going to run the new Windows client, lapse client, in this legacy mode, you can continue to that will allow you to use any of your existing automation. I know that a lot of customers have automation that queries their on-premise Active Directory looking for devices that have failed to update their lapse password in past a certain interval. So that's usually a sign that something's wrong with the device or that it's offline. But you can those will all continue to work until the Windows client has been configured to use the new lapse GPO. It'll just continue to honor the legacy lapse GPO. As soon as a new modern GPO has been configured that supersedes the legacy one, and when that happens under the precedence rules, we will use the more modern one. So I did one last thing. Let's import the new lapse PowerShell module. Oops. And let's retrieve the password. So you can see here that there is limited admin support in the GitLapse AD password for retrieving the password. You can retrieve it. It gives you this information. Legacy Lapse does not store the local account name side by side with the password. So in Legacy Lapse, this will always be blank. We got the password back in a secure string. We don't get the password update time. We do have the expiration timestamp. Tells you that it came from the Legacy Lapse cleartext password. And if we wanted to, we could also dump it into cleartext. Legacy Lapse doesn't have any support for password history either, so you'd have to move to the new lapse to do that. So there is one limitation here that you do have to honor, and I'm going to demonstrate that right now. So let's do the following. Let's clear the event log just so it won't clutter it up when we look at it next time. And I'm going to install the lapse GPO client-side extension DLL on this managed client. Oh, that's just what we want. We don't care about the management tools. We just want the GPO extension. Okay. Now, what I'm going to do is I'm going to try to tell the new inbox lapse client to do a forced reset of the password. And let's go see what happened. So we're now starting. Policy has not changed. But now it tells us. So the machine is configured with legacy lapse policy setting, but a legacy lapse product appears to be installed. The configured account's password will not be managed by Windows until the legacy product is uninstalled. And then alternatively, you may consider configuring the newer lapse policy settings. So I wanted to show this and explain why it's happening. So if you consider what's going on here, we have two agents on this machine that have now been configured to both honor the legacy lapse GPO settings. We have the new inbox Windows lapse client that is built into Windows, and we now have, because I just installed it, the legacy lapse GPO client-side extension. And given the way that the Legacy Labs GPO CSE works, there's no way to really prevent it from interfering with the password and Active Directory. In other words, the current situation, if we didn't do something about it, would result in both agents trying to manage the password at the same time. It's kind of an obvious point, but that's a recipe for disaster. So what we're going to do is we're now going to go back into the control panel, and we're going to uninstall the CSE. And close that, and then let's retry that reset password, and hit refresh. So we are doing like same policy settings, going to AD. We're doing a forced rotation because we requested it. That DC successfully updated AD this time. Awesome. Okay. And if we rerun the password retrieval, we can see that the password did get updated, and we have a slightly refreshed expiration timestamp. Lastly, there is one other limitation, that the ADUC snap-in does not support the display of the Legacy Labs GPO, the Legacy Labs account password. So if you're going to be, this is meant to be a short-term stopgap to help you get through a transition period. We know that it takes time to roll out new devices, in many cases a very long time. But what you can do here is as you slowly roll out the newer Windows clients, you can have them run in Legacy Labs mode, and eventually, as you start to get more and more of these devices, or you decide to run the newer devices in New Labs mode, you can do that. And for the record, we do strongly recommend that you do move to using the new Labs GPO because of the security improvements, especially the password encryption. So that is this demo. I hope this helps you understand a little bit better about the interaction, or the support we have rather, for Legacy Labs emulation mode in the new Labs feature. If you have any questions, let us know. Thank you very much.
In this video, I'll demonstrate how to generate reports for Windows Autopatch. In Microsoft Endpoint Manager, select Reports, followed by the report you want to generate. Windows Quality Updates in this case. You'll start on the Summary tab, so select the Reports tab to generate the report. In this case, I'm creating a report on the current update status of all enrolled devices. Select the Historical report to show the last 90 days of device status updates. You can also generate reports on eligible and ineligible devices. For more how-to information about Autopatch, see aka.ms/Autopatch.